Welcome everyone. Finally we're here. US-Mexico Transboundary Groundwater Conference, the best conference of the year for us, at least. And we're very excited to have you here. It took us a while to get to here this day. I hope all of you from all over the world actually are safe, healthy, and happy to be here today. We have an extremely great, fantastic program today. So hopefully you all enjoy it. We have a lot of things going on. We will have a lot of presentations. We will have breaks. We will have happy hours. We will have calavera contests. We will have a lot of things going on. So please welcome, feel relaxed. If you're part of the program, get relaxed. We're going to take care of everything, and I'll be here to guide you. So a couple of instructions. First, translation services. We have our simultaneous translation, English and Spanish. Please go down to your screen and select interpreters. Select the language of your preference, and after that, please choose the option mute the original audio. That way you can only listen the language of your preference. If you have any questions, please just use the chat of the session. We're going to take care of all your questions during the chat and during the complete session. We have a blog that is up, that is live. You'll see in the chat, you'll see the link to the blog. If you want to start discussions on your own, please do so. We are also live in YouTube. We're live streaming in YouTube. You'll see the link there in the chat too if you want to share it, if you want to join later, if you want to watch it later. We are live there too. So we have a lot of things going on today. And we're trying to reach as many people as possible because this is really a hot, interesting, and very important today. Transboundary groundwater resources between Mexico and the US. I will be your time tracker, so you probably will hate me by the end of the day because we will be very strict in terms of timing. We want to make sure we hold everyone here today in terms of time, and we have enough time also for discussions. So I'll be here, and I'll be telling you, for speakers, panelists, moderators, how much time we have left. Okay? So as the objective, very important, let me just read it. To explore and analyze innovative perspectives of transboundary groundwater resources management between Mexico and the US, and to develop strategies to assess current and future transboundary conditions from technical and managerial and environmental perspective. This might sound complicated. It is complicated, but it's really what we need to do. Let me just give you a quick background. So what are we? I mean, where are we today in terms of transboundary aquifers between Mexico and the US? In terms of knowledge and data, we are limited in knowledge, we have limited data, we have limited communication, and we have limited institutional framework. We know that. In terms of challenges, we have population growth expected to duplicate in the 20, 30 years coming. We have climate change challenges as everyone else in the world. We have the lack of trust. We have recognized that on our past events. We have lack of leadership and lack of willingness as well. And I will also add the word fear when it comes to groundwater in the border. Now, in terms of timing, we do have a momentum right now. Shared water issues between Mexico and the US are getting high in the binational agenda, as you all know. And so is the topic of transboundary groundwater. So we're happy. We're happy of this momentum, and we're going to take advantage of it, and we should take advantage of it. We have an election year in the US, and we have a new national water law under discussion in Mexico. So this is a good time for everyone. This is an interesting momentum, so we should make the most of it. And we should make sure that we provide something useful out there for people to use, for the decision makers. So what do we have in our favor? We have one of the most knowledgeable people, experts on the topic of the world here today. We're pretty proud and thankful for that. We know what the problems are. We will see them today. We might not agree or be clear on how to address the issues, but we surely know what we should not do. So that is a great start. So let's plan on how we can do. It's time to open up, to let water speak for itself and unite us. So with that, I'm going to open the table, and I'm going to give the word to John Tracy, who is the director of the Texas Water Resources Institute. And I must say that this effort was jointly organized between Texas Water Resources Institute and the Mexican Instituto Mexicano de Tecnología del Agua. I better use that in Spanish. I better say that in Spanish. We are very proud to have this project together. And finally, after a couple of years, we're here. So thank you, Mexico. Thank you, IMTA, for this. And I'm going to give the word now to John Tracy.
Thanks, Rosario, and thanks, Sam, for getting all this together. I know there was a really big effort to get this together, and I remember about last January we were talking how we're going to have this in McAllen this week, and then a few things happened along the way, and it just impresses me how adaptable and innovative everybody was to be able to pull this this meeting together in the format that it is. So I want to welcome everybody. It was a little under 5 years ago when I started at Texas A&M, and one of the first things that happened was this announcement that I received from Sharon Megdal and Sam Fernald, my counterparts at the Arizona and New Mexico Water Resources Research Centers and Institutes. And there was a program called Transboundary Aquifer Assessment. And it was very interesting. I didn't know anything about it until they sort of called me and sent me emails. And out of that has grown a tremendous collaboration and actually development of a worldwide agenda talking about not just governance and policy issues surrounding transboundary groundwater, but really understanding transboundary groundwater as a subject matter, and also understanding how to share information and develop forums like this so that's actually discussed in a more open format rather than, how shall I say, in the past, maybe deals made in back rooms. And so I think this is just sort of the next step in getting to a more transparent discussion about these transboundary resources, and sort of the next step in how we're going to move forward with sharing information and eventually moving to some type of a way to better inform policy with all of the changes in government and climate that are going on across the world. And with that, I want to thank everybody again and have a good time at the conference. And I'm going to turn it back to you, Rosario.
Thank you, John. Now, please let me introduce Adrián Pedroso, who is the director of the Instituto Mexicano de Tecnología del Agua. Thank you, Adrián, for being with us today. Thank you for all the hard work. Thank you for the effort. Thank you for the leadership. And, of course, thank you for the example.
Thank you very much, Rosario. I'm going to speak in Spanish as I am representing the Mexican government. Bueno, primero que nada quisiera desde luego reconocer también el trabajo y el liderazgo del Instituto Tejano de Recursos Hídricos, a través desde luego del doctor John Tracy, acompañado de Rosario Sánchez. Y del lado del IMTA, pues desde luego de nuestro coordinador de hidrología, Agustín Breña, quienes realmente fueron los constructores de este evento que nos ocupa el día de hoy. Yo quisiera, a nombre de la maestra María Luisa Albores, extenderles la más cordial bienvenida, decirles que desde el Gobierno de México estamos trabajando arduamente justamente para incorporar las discusiones académicas, los resultados y la evidencia científica en la toma de decisiones del gobierno federal, en beneficio de todas y todos los mexicanos. Hoy estamos viendo que la crisis ambiental que nos ocupa y la crisis de salud dada por el COVID-19 nos ha hecho evidente que hay una relación intrínseca entre actividades humanas, salud del planeta y nuestra propia salud. Por eso las discusiones como la del día de hoy son fundamentales. necesitamos desarrollar estrategias de atención y metodologías que nos permitan anticipar conflictos sociales y afectaciones ambientales que resultan de la interacción entre agua y sociedad. Dentro de las urgencias provocadas
Adrián,
por...
Adrián,
Sí, perdón.
un favor. Lo que pasa es que si te puedes cambiar al canal de español para que
Correcto. ¿Cómo hago eso?
en la parte de abajo viene, en el menú de abajo viene uno que dice interpretación y te vas al canal de español y vamos a escuchar tu traducción.
A ver, díganme,
Gracias.
¿es correcto? Está bien ya, ¿verdad?
Mhm.
Ya.
Muy bien.
Yep.
Bueno,
Ujú.
como les decía, hoy nos ocupa justamente uno de los problemas fundamentales respecto al agua en el mundo. Está registrado que el uso proveniente de los acuíferos y los ríos excede por mucho los límites deseados de sustentabilidad en todo el planeta. Y de hecho, los países con mayor sobreexplotación de agua subterránea son también aquellos grandes exportadores de productos agrícolas, ¿no? Como es el caso, por ejemplo, de México. Hay un estudio de Tom Gleason del 2012 en el que ya nos indica que el 20% de los acuíferos en el mundo exceden la disponibilidad, o sea, están sobreconcesionados. Y por si esto fuera poco, cerca de 1.700 millones de personas en el mundo viven en regiones donde ya las extracciones exceden la disponibilidad. Entonces, estamos ante un tema por sí solo, el del agua subterránea, altamente complicado, que además, en regiones como el norte de México o el sur de Estados Unidos, donde la escasez de agua superficial y el clima árido imponen condiciones climáticas mucho más complicadas, pues hace de su tratamiento una actividad en la que debemos entrarle con todo el conocimiento. Yo estoy seguro que el evento de hoy conforma un primer paso hacia la necesaria cooperación de buenos vecinos. Por eso este evento está ocupado en una primera aproximación con base científica. Tenemos que reconocer el valor que representan estos acuíferos en los aspectos de nuestra vida, de nuestro desarrollo económico, y también por ello necesitamos establecer una manera conjunta de cuantificar su disponibilidad y su gestión en beneficio de los dos países. Entremos pues a conversar sobre The Elephant in the Room, y como dice el dicho israelí, no hay peor cosa en el mundo que un vecino con sed. Muchas gracias, mucha suerte y que sean unas discusiones muy provechosas las de...
Thank you, Adrian, very much. Thank you for being here today. Hopefully we'll see you in person sometime soon. Okay, and next, I'm going to give the microphone to our IBWC, International Boundary and Water Commission Commissioner, Jane Harkins. Thank you, Commissioner, for being here today, this morning. It really means a lot to us. It really means a lot to the topic, and it really means a lot for the binational agenda. So thank you. And please, you have 2 to 3 minutes.
Okay, thank you. Appreciate the invitation to join you today. I know it's not the same as being in the same room with all of you, but I do applaud the sponsors for continuing in this new forum. I think it does help us to continue to have these dialogues and these discussions. In 2009, the Commission made a commitment to implement a Transboundary Aquifer program along the U.S.-Mexico border. The objectives was fourfold in that process. The first goal was to facilitate the exchange of data between the two countries, facilitate the agreement of aquifers to study jointly, to establish binational technical work groups, and to also create an official repository for the data and the research. The U.S. section has worked to implement
Okay, we're losing her. Commissioner, I don't know if you can hear me, but we can't hear you.
groundwater.
Oh yeah, we got
Not sure we need those.
We're good. We're good. You're back.
Am I back? Did you miss
No.
anything?
Yeah, we missed a couple of seconds, but now you're back.
Okay. Anyway, before I get lost, I guess I'll wrap this up. Our region on the border really has faced challenges of water supply that, of course, affects both governments. It affects all of the communities along our border, and it affects all of our businesses and our economics. Finding solutions and creatively finding strategies to meet our water resources needs on the border is very important. And one of the primary things that we need is ideas across the border and strategies between both countries with shared data, and of course with mutual respect and transparency, that we agree to the data and we can come to solutions on a binational basis. That's very important to us. To me, today's event exemplifies what was envisioned under that agreement, to look at the state of groundwater along the border, conduct research, have that discussion, and share that data and information. I just want to thank you for the invitation. I think this is great that we're doing this so that we can learn from each other and again, help each other work on an integrated strategy and from a science-based strategy and to create policies that we can develop from those science-based strategies to help with the water supplies along the border. Thank you.
Thank you, Commissioner. Good morning. Hope you can stay with us the rest of the day and tomorrow, which will be great. So let's move on with our program. I want to introduce our Q&A moderator and chat moderator and security moderator and everything, Sam Sandoval Solis. He is Associate Professor in Water Resources Management at the University of California, Davis, and Associate Director of the Permanent Forum of Binational Waters. Thank you, Sam. You know you are a big thank you. So thank you for being here today.
Thanks, everyone. Muchas gracias. Bienvenidos. Welcome, everyone. Yeah, I'm gonna be, so a couple of messages here. I am putting on the chat the instructions if anyone wants to join or get this in Spanish. Puse las instrucciones en español, muchachos, para que se puedan conectar. So that's one of the first things. The second one, I'll be doing some of the, I'm also working on, I'm going to be collecting a lot of the Q&A. So put your questions in the chat, and I'll be putting all of them together. And let's have fun. Let's make a little bit this more interactive. Welcome everyone. Bienvenidos.
Gracias, Sam. Thank you, Sam. Okay, let's move on. This is the morning program today. We have a keynote lecture, we have a discussion panel, then we have a network breakout presentation, pretty interesting, and a theme lecture before we go into break. We don't want to really fill you up with everything this morning. We want you to take a long break, and then we're going to come back in the afternoon with a couple more sessions, and then a very, very, very happy and joyful happy hour, if that sounds redundant. Okay, so let's start with our first keynote lecture, Climate Change and Transboundary Groundwater Systems. And that's going to be offered today by Dr. Paul Chris Milley. He's a research hydrologist at the U.S. Geological Survey. His research focuses on the interaction between climate change and the terrestrial branch of the water cycle. Chris has given testimony and briefings to the U.S. Congress and has been interviewed by dozens of major media outlets. He's a fellow of the American Geophysical Union and the American Meteorological Society. Thank you, Dr. Milley, for being here today. And I'm going to give you now the floor. Gabby?
Okay. Can you hear me?
Yes, we can hear you.
Okay, great. Thank you, Rosario. Let me begin with an explanation. The title of my talk is quite different than what you saw in the program. When Augustine and Rosario invited me to speak, I confessed to them that I know very little about transboundary groundwater flow and about politics and economics and water management. They assured me that our work is very relevant to this conference because it provides a scientific context for the issues that you'll be discussing. I think that's a wise call on their part, and I'm happy to be able to share some of what we've learned in our research. You know, the Colorado River Compact of 22 and the treaty of 1944 were both drawn up without knowledge of anthropogenic climate change or even of natural climate variability. We are now experiencing climate change, I don't need to tell you, and that it is having profound impacts on water availability in southwestern North America. So this is indeed, in the sort of subtitle of the conference, an unprecedented challenge. Now, I have not done any formal analysis, what climate scientists would call detection and attribution, but I can say that severe drought in Chihuahua is consistent with expectations from climate model analyses. On the other hand, I have taken a very close look at what has been happening in the upper Colorado River Basin in the western US. And that's the work that I'm going to describe briefly. Its general relevance to this week's conference is conveyed right there in my title. Groundwater becomes all the more important as the surface water supply is decreasing. I'll also describe briefly the specific relevance of this work to the current situation in Chihuahua at the end of my talk. And if I forget to do that, don't forget to remind me.
Oh yeah, I will remind you.
Q&A, thank you. Finally, by the way, the research that provides the basis for this talk is documented in a paper that appeared in the journal Science in February of this year. And if you wish, you can email me at cmillie@usgs.gov and I'll send you a copy. I'm sure there's contact information in the program somewhere. Okay, let's see. On with the show.
Next.
Yeah, so there it is. The upper Colorado River Basin is the region of study that I addressed. You know, this is demarcated by Lake Powell and the Glen Canyon Dam. And our measurements that we're using are based on those at Lee's Ferry as adjusted by the Bureau of Reclamation for withdrawals and consumptive use and such. So we're going to be working with naturalized flows. What is the actual water resource, the supply? Next. Now, these are three graphs that run from 1910 to 2020. The top is precipitation, the middle is temperature, and the bottom is naturalized discharge, the actual runoff from the upper basin. The last of these, let's say there, the last of these has decreased by 20% at a rate of 20% per century over the last century or so, even as the precipitation was more or less constant or actually increasing a little bit, as you can see in the top graph. The middle graph is the time course of temperature. And as you see, and as you know, the Western North America has been warming more or less consistent with the global warming. And so there has been speculation, well, the decrease in naturalized discharge has to be associated with that temperature increase. And that's more or less true, but it's a little more nuanced than that. Let's go on. Next. We have this quantity I'm going to introduce here, beta. Beta is it tells you how much in percentage terms the naturalized flow from the upper Colorado River Basin changes for a 1 degree Celsius of warming. So the actual value of beta has been highly uncertain for many years. There's a lot of literature out there with wide-ranging numbers, and this obviously adds a lot of difficulty to the problem of management. One thing that's clear is that the value of beta is negative. That is to say, warming reduces runoff. Next. Now, just to illustrate how sensitive or how uncertain this quantity beta is, and take a look at this graph. Now, the 0 is at the top, and then it goes downwards is a negative, increasing sensitivity, negative sensitivity of the river's output to temperature. So these studies that did kind of regression analyses came up with estimates of 13, 14, 15 percent decrease in flow for each degree of warming. These are enormous decreases. Click once now. There's another approach in the literature. It's not regression. It's people running dynamic process-based models with imposed changes in temperature. And those models spit out much lower estimates of the sensitivity. And even within that approach, there's a wide range of variability. It's very interesting that all of those studies taken together have no overlap with all of the regression-based studies. So we have anywhere from a 2% decrease to a 15% decrease for a degree of warming. I'm not talking about changes in precipitation yet. We'll address that briefly at the end. But the warming is something we're so confident about that it's worth considering this particular sensitivity. One more click. We also have some theoretical results that suggest the sensitivity is down toward the very low end of these numbers. One more click. And again, I guess. Yeah, so a year and a half ago, there was a workshop convened in Colorado to address the question of why is there such a wide uncertainty in this range of beta in the scientific literature. And so all these great people, I mean, these are the big names in the area of the scientific study of this problem, got together. And before the workshop was held, the organizers sent out a survey to ask people what they thought the sensitivity of the Colorado discharge to warming was. And that resulted in this graph on the picture here, this bar graph. In this case, the zeros at the bottom and going up indicates increasing sensitivity. The bar represents the range that each participant thought the sensitivity fell within. So participant number 1 said, well, I think it's between 3% to 12% per degree C. Participant number 2 is very confident that it's 6%, and so on. If you look at the overall range here, it goes from a 3 to a 15, which is what I showed you in the previous slide was what the literature supports. So the point is that at the beginning of this workshop, the cumulative literature up to that date had really not resulted in any convergence of opinion on the sensitivity. Well, the most interesting thing about this is at the end of the workshop, after all the discussion and presentation of the latest results and discussion of review of previous work, the survey was repeated. And basically, I don't have the chart here, but the chart looked exactly the same. There's no convergence of what this sensitivity is. I had not worked on this problem prior to this. I had just published a paper in general on sensitivity of stream flow to temperature, but not looking at the Colorado system. So that's how I ended up at this workshop. But I was intrigued by this. I was intrigued and I was alarmed by the wide range of uncertainty about this, given the significance of this water resource for the economy, the people of southwestern North America. So that's how I got into this thing, and I'm showing you results that resulted after about a year and a half of scratching my head about the question. Next, please. So I call that the Colorado conundrum. Given this wide range of uncertainty, should water managers trust those empirical regression estimates? I mean, they're rooted directly in the observations. They don't have any assumptions about the processes involved. So, some people would say, hey, that's the way to go. Others say, focus on the dynamic model estimates because they incorporate all the actual physics that we know about the system, and they avoid some potential pitfalls that arise when you use a black box of statistics. So there's a conundrum. What do we do about this? Well, it turns out after looking at the data a lot of different ways and bringing in some data that until now really had not been brought in, specifically data on solar radiation and reflection of solar radiation by snow, we came to understand that a large part of this sensitivity is associated with these little graphs on the right. What they show, any one of them, they're all the same basically. It's just there's 12 panels that refer to different elevations within the upper Colorado Basin. But each one shows the dependence of albedo on the, let's go back one. I don't want that up there, it's confusing. The dependence of albedo on the snow water equivalent on the ground. Albedo is the amount of sunlight that gets reflected back to space such that it's not there to warm the surface. So when you've got a lot of snow, you've got less energy coming into the basin. As the climate warms, the story changes. And please click now. Yeah, thank you. Warming leads to less snow cover by two routes. One is that there's less snowfall because more precipitation comes down as rain. Secondly, the spring is warmer. The melt begins earlier. So during springtime, as a result, there's less snow on the ground. That means you're reflecting less radiation back to space. You're absorbing more of that radiation. What does that radiation do? That radiation is a source of energy. That energy is converted to heat when it hits the ground, and that heat is dissipated in two ways. One is by warming of the atmosphere, but one much more significant when there's plenty of water around is increased evaporation. The surface cools itself by evaporation to dissipate that energy. More sunlight, more energy, more evapotranspiration. Assuming precipitation doesn't change, you've got more evaporation, there's less water left for runoff. The evaporation tax really taxes you, and there's this tiny trickle left over for the runoff. I mean, as you may know, it's already, historically, the runoff from the basin has been a small fraction of the precipitation. Most of it's ET. And this situation with the decrease in snowpack is just making that situation worse. So this is a process that was, oh, go ahead. Let's go to the next. Yeah, click once more. So there's a whole lot of analysis in there, and I'm not going to trouble you with it, but the bottom line is this bar on the right end. The full bar with all colors combined represents the conclusion we reached that the sensitivity is approximately 9.3% decrease in flow per degree of warming. The interesting thing about that, how do you reconcile that with all these previous studies? Well, we did reconcile that. And that's what some of the stuff in the middle is about. I'm not going to go through that, but those very large estimates shown by the red dots, those are based on some statistical issues, problems that caused them to be biased to a very large magnitude. There's some confounding variables that were ignored in those analyses. And we can show that if we make similar assumptions, our analysis also produces those numbers, but they're wrong. On the other hand, those dynamic model estimates and that theory estimate, why are they off? Well, the point is this snow albedo effect I just described on the previous slide is the blue section of this bar. It's the lion's share of the sensitivity. It's why this sensitivity is happening. That's something that was ignored in this theoretical result that I showed. And it's something that was in some of the other dynamic model estimates included, maybe, and in others it was not. So basically, we've come up with what we think is a pretty firm estimate of the sensitivity to temperature, and we've reconciled it with these previous estimates. Next slide, please. And, this is the bottom line. What does this same model, we used a model in order to do this research. It was part of the tool. And we can then apply this model to talk about the future. We drove this model with outputs from some climate models. We filtered the set of climate models such that they were had somewhat representative climates corresponding to the real world in this part of the world, where climate models in general do not do very well. We only used 1/3 of the available climate models, and we took from them the back up one, I think, because it'll get distracting.
Chris, you only have 2 minutes left.
Oh, okay, thank you,
Okay.
great. If we consider only the effect of the projected temperature change, we get under one scenario of climate change a 14 to 26% runoff decrease. Under the next one, RCP 8.5. Next, please. A 19 to 31% runoff decrease, i.e. those differences in emissions do make a difference. If you include the effect of precipitation, precipitation is still a wild card, and it just widens the uncertainty range. Anywhere from a 5% to 24% runoff decrease under 4.5, and I think a slight increase, 3% to a 40% decrease under 8.5. So, you know, the bottom line is, well, here, Colorado River Basin is losing water, and I've explained the mechanism already. I've talked about reconciliation. The future, the strong temperature sensitivity implies that the UCRB discharge will decrease under almost all scenarios, despite the uncertainty in future precipitation. I think that's all. Next. Yeah, that's all. Okay, we're done.
Thank you,
yeah.
Chris.
Thank you, and
said
thank you for
to
the timing.
You said to remind you on a comment you wanted to say it on current
Yeah,
conditions.
Yeah, so you know, we saw this great temperature sensitivity in the upper Colorado. I would say that that likely is not transferable to the sources of runoff like in the Chihuahua state because of the absence of snow as a main source of water. So on the one hand, the warming is not as much a problem for reducing the water supply. On the other hand, whereas in the Colorado Basin, it's not clear which way precipitation change is going, although evidence suggests it's getting drier. In farther south, in the Mexican states and in the southern ends of the US states, the climate change projections are pretty clear that precipitation reductions are going to be experienced, and therefore, you know, what's being experienced of late there is fully consistent with the climate change projections.
Okay. Thank you, Chris, very much. We're going to go to questions.
We have a couple of questions here from Allison. So one is, does the flow sensitivity to temp vary with the total annual flow? And then the second one, which is the last one, how do you think the sensitivity may vary when comparing specific river segments, which might be dominated by different components of the water budget? Maybe this was part of your study. What was the spatial scale, the entire river? So two different questions.
Okay, so concerning the Q sensitivity to temperature varying with annual Q, yes. You know, this whole beta idea is just an approximation, a rule of thumb, and in fact, as warming progresses, the sensitivity appears to decrease somewhat. So as Q is decreasing, the sensitivity actually decreases somewhat. Additionally, the sensitivity depends on really what time of year that warming occurs. These works all assume a uniform distribution of temperature change through the year. Now, river segments, which may be dominated by different components of water. Yeah, this was not part of our study. We simply looked at one output variable, if you will, which was the unregulated flow into Lake Powell. So yeah, we modeled the whole basin. We modeled it at a 4-kilometer resolution. So we got all the high runoff areas up in the high mountains, but we aggregated everything down to the point on the river. In fact, we're following that up with more detailed spatial analysis right now.
We have a couple of two more questions. One from Debbie. Debbie, you can send you here a question for the, you can see also them on the chat. How does the kind of information get to water managers, users, and other interests? What are the channels for disseminating this critical information? And then Joel is also putting another question there. How groundwater extraction was considered and water used for development? Okay, let's go with those two and later we'll go with Bill's question.
Yeah, I'm sorry. So Bill Hutchinson to everyone, 11:42 a.m. Is that?
No. I was thinking, no, Debbie Van Nient.
Bill also sent a question.
Yeah.
I'm trying to see on the screen so I can read it. My eyes work better than my ears.
Yeah. So how are you doing the outreach of this information? Who are you sharing, or do you have any sharing campaign for stakeholders? What are you sharing?
Right.
Information.
Minimal. I wait for people to invite me to something like this. You know,
okay.
And through the press. I mean, this was covered very widely in the popular press. Yeah.
So let's go to Joel's question.
The question I can answer about groundwater extraction and water use. What we did was we took at face value the reconstructions of naturalized flow made by the Bureau of Reclamation, which accounts for extractions, return flows, losses in irrigation. Surface water, groundwater, historic stream flow, depletions. Yeah, again, that the groundwater depletion is accounted, although not by me, but in adjustments that are made in the data that we used as input to our analysis. Can this temperature change directly affect trading on evapotranspiration agreement in Mexico, USA? It certainly affects the physical system. Beyond that, it's up to you guys to deal with that. The USGS tries to do policy relevant science, but does not address questions of policy.
Yeah.
Rule of thumb, that's an interesting question. The basic rules of thumb are the concept of this beta, and there's another thing called alpha, which measures the sensitivity to precipitation. And alpha is like 2.5, meaning for a 1% decrease in precipitation, you get a 2.5% decrease in discharge. So that's a rule of thumb. Yeah. Oh, uncertainty in the withdrawal volumes, I don't know. Again, as I say, I take the Bureau of Reclamation's estimates at face value.
Do we have any other questions? Should we? Thank you, Chris, very much. If you still have more questions or thoughts on this, please log into the blog and we can follow the discussion live there too, or even the YouTube channel. So
okay,
we're gonna.
Thank you all for your questions. I really appreciate also the chance to speak. Thank you. Thank
you, Chris, very much. I hope you can stay the rest of the day with us. So we're gonna have a discussion panel number 1. We're gonna have a couple of speakers here. The title of the discussion panel, Kevin, can you go back a little bit? Groundwater depletion and groundwater security in the Rio GrandeBasin Basin versus the Colorado River Basin. The moderator of this panel is Dr. Agustin Breña Naranjo. He is Deputy Director of IMTA Mexican Institute of Water Technology. That's the way I should say it in English. Dr. Breña is expert in hydrology and water resources management. Prior to its appointment at INTA, he was associate professor at UNAM. His main research interests are remote sensing of the water cycle, drought monitoring and validation, ecohydrology of drylands, and water energy nexus, quantitative impacts of fracking on water resources. He is a member level 1 at the National System of Researchers from CONACYT and was awarded the 2019 prize for Best Young Investigator at UNAM. So Agustin, I'm going to leave you now the ground so you can introduce your panel and go ahead with your questions.
Good morning, everyone. Thank you,
Agustin,
Rosario.
can you take over now?
Yes. Can you hear me? Hello? Can you hear
Is
me?
Agustin connected, Sam? Yeah? He's probably muted. Agustin,
Yes, can you hear me?
I can see you, but we can't hear you.
I can hear him in English.
I can hear him too. Perhaps it's the channel.
I
It's
can
okay.
hear you.
It's okay.
Okay. Well, thank you,
Let me see.
Rosario. Good morning, everyone. So I'll be moderating the discussion panel number 1 that is about the groundwater depletion and water security in both transboundary basins, the Rio Grande as well as the Colorado River. And we have 3 panelists, 2 from Mexico and 1 from the US. I will introduce them. We have Mr. Julio Soriano from Mexican Institute for Water Technology. He has a degree in civil engineering and a master's degree in engineering with
Oye, Agustín.
Yes.
Hola, Agustín. Bueno, si quieres hablar en inglés, cámbiate al canal de inglés. En la parte de abajo debe de venir uno que diga
Agustín, cámbiate al
interpretación.
canal en inglés, por favor.
Yes, that's what I did. Okay.
Sí,
And he has a master's degree in civil engineering with a specialty in integrated water resource management, both from UNAM. He has served as a coordinator of studies and projects in the Institute of Engineering at UNAM, the National Water Commission, CONAGUA, and he's currently Deputy Coordinator of Surface Hydrology at IMTA. He has a recognized career in the study, observation, and monitoring of extreme hydrometeorological events such as droughts and floods, and the sustainable management of water resources. Then we also have Dr. Sharon Megdal from the University of Arizona. She's director at the University of Arizona Water Resources Research Center, and she's a distinguished outreach professor. Her projects include comparative evaluation of water management policy and governance in water-scarce regions, groundwater recharge and transboundary aquifer assessment. She has worked collaboratively with researchers and officials from Mexico for more than a decade, and has served as a member of the Central Arizona Project Board of Directors for 12 years. Dr. Megdal was named the 2020 recipient of the Warren Hall Medal for Lifetime Achievement in Water Resources Research and Education by the University's Council on Water Resources. And finally, we have Dr. Antonio Hernandez, also from UNAM. He is geological engineer from UNAM, and he has a PhD in environmental hydrogeology from the Complutense University of Madrid in Spain. He's a research professor at the Faculty of Engineering from UNAM, where he leads the academic activities of the hydrogeology group. He's a former head of the Earth Science Division and at the engineering school, and a former visiting researcher at the Bureau of Economic Geology from the University of Texas, Austin. His main research topics include quantitative aquifer assessment, environmental and land subsidence process, well test analysis using advanced techniques, and water footprint analysis in shale plays within a transboundary context. Thank you very much to all these 3 panelists, and I will start with the first question. Each one of you will have maximum 3 minutes to answer, and then we will continue with the next questions. So the first question is, how does climate variability impact groundwater availability at the Rio Grande, but also in the Colorado River Basin? So we'll start with Julio. Go ahead.
Thanks, Agustin, and the organizer for this invitation. Welcome to all. The ability to observe large-scale change in water resources has been improved by the development of Earth observation satellites. One of these satellite missions is the NASA Gravity Recovery and Climate Experiment, or GRACE, which measure temporal variations in the Earth gravitational field. These observations are now applied to estimate the monthly change in water storage. Studies have shown that GRACE observation, when are combined with datasets of surface water and storage and soil moisture in a mass balance, can quantify the change in water storage with accuracy. To answer the question, I did an analysis of 18 years from 2002 to 2020 of observation from GRACE in order to quantify the change in the storage of fresh water in the basins of Colorado and Bravo rivers. The results in Colorado basins show that in the study period, the entire basin lost a total average of 23.3 cubic kilometers of fresh water, with an annual loss rate of 1.3 cubic kilometers, and the most critical loss since 2011, with an average loss rate of 11.3 cubic kilometers of water per year. The most prominent hydroclimatic change in the basin over the last 40 years has been the warming trends. Trends in temperature, precipitation, and snow cover, methane, and runoff can be seen in the table on the right, as well as the causes in order of importance. The next one, please. Similar results are observed in the Bravo Basin. However, they are more critical, as you can see. Through the study period, the entire basin lost an average total of 76.8 cubic kilometers of fresh water with an annual loss rate of 4.3 kilometers of water. The most critical loss since 2010, an average loss rate of 10.2 cubic kilometers of water per year. It can be observed that since the draw event between 2011 and 2012, identified in the red box in the upper panel, that shows the precipitation anomalies, the system has not recovered. To continue in the research, the next step is to separate the variation in surface water from the accessible water to get the variations in groundwater. However, it should be noted that the results in the previous similar studies indicate that the groundwater may comprise a very important fraction of the water used in these basins, especially when there is a drought, which suggests that there is a significant depletion of groundwater in these basins. Thank you.
Thank you, Julio. We'll continue with Sharon McDowell from Arizona.
Thank you, Augustine. Did you say we have 3 minutes?
Yes.
Okay, we were told earlier 3 to 4. I'm starting my timer. Good morning, everybody, and it's my pleasure to be here today. I want to thank the organizers for organizing the conference, and looks to be an excellent program. So I was very excited with Chris Milley's talk because he showed this very map that I have up here of the Colorado River Basin. And because everybody in the audience is not necessarily familiar with the two basins, I wanted to point out that the water from the Colorado River Basin, or from the Colorado River, supports up to 40 million people in some way, shape, or form. Water is delivered outside the hydrologic boundaries. So Chris was focused on the snowpack and the runoff and evaporation in the upper basin, which is the source water for the Colorado River, because there is no snow in the lower basin. But if you looked at those red hatched marks, they show where in the United States, and maybe you can put the arrow over the Los Angeles area so they see what hatch marks I'm talking about. water is delivered outside the basin to significant populations. And the point that Julio just made about the use of groundwater and what will happen to the use of groundwater in drought conditions and under climate variability is a key point, and the key point that I wanted to make here. Surface water and groundwater are substitutes. There is quite a lot of dependence on fossil groundwater in the lower basin. This middle chart shows the monitoring of the surface water reservoirs in the Colorado River Basin. There is no storage, surface storage south really of Lake Mead. There's just a little bit. And this is as of September 21st of this year. And you can see the reservoirs are well below capacity, the big reservoirs, and they're managed in a joint way per the shortage sharing guidelines signed by the Secretary of Interior. Because of these low levels, there is curtailment of water deliveries for the first time to the lower basin, particularly to central Arizona. And that is leading to increased use of groundwater. And so on the right, what I show is the active management areas of Arizona where there is dependence on groundwater. Next slide. The second slide just shows what's going on in Arizona in terms of as the lake levels go down. This is a photo of Lake Mead taken last May. It's well below capacity. There are curtailments that are happening now, expected to get more significant over the next several years. And that affects agriculture in particular in central Arizona. And what is happening there is they are going back on the pump. So I will leave it at that and talk about some of this in the next question.
Thank you, Sharon. And then we'll go with Dr. Hernandez.
Thank you very much. Rosario and Agustin, thank you for having me here. I hope everyone are safe and healthy during these difficult times. Well, to answer the first question, climate variability and how it affects groundwater, it's very important to say that in the study area, I will be focused more on the Rio Bravo Basin. We have a very complex transboundary aquifer systems. So climate variability affects in very different ways the two main hydrostratigraphic and groundwater flow systems that we have here. We have one shallow aquifer system comprised by alluvial and clastic sediments, and that aquifer is certainly more affected by climate variability. On the other hand, we have a very deep aquifer groundwater flow systems related to the karstic rocks of the Basin and Range province and the karstic deformation of the Cretaceous rocks, and that deep confined aquifer is more climate resilient. As you can see in this second figure, the precipitation is quite low. It's in the order of the precipitation is in the order of 300 to 400 millimeters per year. So groundwater is the main water source to supply irrigation, to supply domestic and industrial users in the region. The aridity index in the third figure is also we have an aridity region, so shallow groundwater is definitely more affected by climate. Something happened here.
Gabby?
That's not me, for sure.
Somebody wanted to share their screen. Here we go again. Here we go.
This happens, don't worry, Rosario. Okay, we're back. Yeah, so basically there are two different groundwater systems, and climate variability will affect the shallow aquifer in more significantly. However, the shallow aquifer is the main groundwater source. The deep aquifer is less exploited in the region and less studied, especially in the Mexican side. Next one, please. Okay. In addition, there are several parts of the Rio Grande Basin, as you can see here, that negative groundwater trends levels has been observed, and also some recovery groundwater levels during late fall and winter, suggesting in fact that high head variability are associated with climate conditions, but basically in the alluvial and the clastic shallow aquifer. And this is very important to understand because, for instance, the CONAGUA, the Mexican Water Authority, considering one aquifer as a whole. They are not separating the two groundwater flow systems, and this is very difficult to assess. Also, and in the right figure, you can see a grace anomaly from 2001 to 2017. And as you can see here, the terrestrial water anomaly, including groundwater, surface water, and soil moisture, are particularly influenced by multi-annual droughts. You can see here this huge grace anomaly decrease from 2011 to 2013 droughts. And this is decreasing mostly vertical recharge. So seasonal and extreme events are the main vertical recharge process affecting, again, the alluvial aquifer instead of affecting the deep one related to the karstic rocks. Next one, please. So the key points of the question number one is that the Rio Grande or Rio Bravo Basin shows, in fact, large space-time climate variability, limiting natural water availability mainly in the middle basin. Alluvial and clastic unconfined aquifers, for instance, the Sabina-Reynosa Formation, are largely affected by seasonality of precipitation, limiting vertical recharge. But on the other hand, the confined karstic aquifers related to regional flow systems, for instance, the huge formations Cupido and Aurora, are more climate resilient. And we need to understand the hydraulic connection of these two aquifers systems. And lastly, the extreme droughts may affect long-term shallow groundwater flow and storage, which is the main water source in the basin. Particularly in the Mexican side, the hydraulic connection between shallow and deep confined aquifer systems remain unclear. And that's it for question number one.
Thank you very much, Antonio. Then we will go with next question. Does the U.S. and Mexico need novel hydro diplomacy and governance tools under the expected climate change scenarios? Is there any difference between both basins? We'll start with Mr. Soriano.
Thanks, Agustin. The answer of the question is yes, of course. I showed in my previous intervention that there are similar trends in the climate variability in Bravo and Colorado basins, which is more critical in the first one. However, it must be recognized that they are different systems. Colorado River Basin has a total area of over 657,000 square kilometers, of which almost 98% are in the United States. It has estimated average annual runoff of almost 20,000 million cubic meters and an estimated water allocation of more than 21,000 million cubic meters per year, of which 1,850 correspond to Mexico by the 1944 treaty. That are equivalent to the 9.4% of the river's average annual runoff of the river. Bravo River has a total drainage area of almost 472 square kilometers, of which little more than a half are in the United States. It has an estimated average annual runoff of more than 10,000 million cubic meters, of which almost 6,000 are runoff in Mexico. Mexico has an estimated water allocation of over 7,000 million cubic meters of water per year by the data of the National Water Commission. We can observe that in both cases, the water allocation gets over the annual average natural runoff of these rivers. The next one, please. Agreements around these rivers arose through the most advanced hydrological studies for that time. However, did not have in mind issues such as the long-term effects of the climate variability, the lack of water allocation for environmental purposes, prolonged periods of severe droughts, and the increased water of demand for irrigation and population, and changes
1 minute left.
in use in their impact, for mention some of them. But about these novel diplomacy and governance tools, first, it's important that all stakeholders must be involved in the cooperation process. Second, as Galileo said, measure what can be measured and what it doesn't, make it measurable. A resource that is not measured can be regulated. Third is the value of creation that refers to the more efficient use of water that satisfies multiple priorities and interests. Another tool is the adaptive management, making continuous adjustments to previous decisions through the new knowledge and new information and changes. It's important to have a mutual benefits approach where negotiations should be based on the benefits derived from water rather than the water itself, seeking benefits for all equally. And finally, the decisions must be made based on the science and technology available to implement effective solutions. This is of the question number 2. Thank you.
Thank you. Julio will move with Sharon.
Yes, thank you. And for some reason I texted Sam. I've lost the ability to see the slides, but Ellie, if you would put up the first one. This question is about the need for novel hydrodiplomacy and governance tools. And I guess I would like to focus my response on saying that we have actually a very good foundation. We have, with the International Boundary and Water Commission, we have the ability to do novel things, and novel things have been done and adapt. There's been great adaptation to build upon Julio's comments. So I show snapshots there of minute 242. I think one of the questions relates to the earlier question about groundwater. How much, what kind of tools do we have to manage groundwater in the transboundary binational setting? And there are different viewpoints about the extent to which the 1944 treaty as it stands envisions groundwater management. And minute 242 for the Colorado River is about the only mention of groundwater, as I understand it, in the treaty and minutes. So that's an area where it's been used to build upon, but is it sufficient? So I would leave that as a question. If you would go to the next slide. Again, I think the two countries have been innovative and adaptive to changing circumstances. And in this case, I want to talk about the response to the Easter 2010 earthquake, April 4th, which happens to be my birthday. I always like to point that out. I always remember the date of it. And this is a case where, because of the earthquake and the damage to delivery infrastructure in Mexico, Mexico would not have been able to take its full entitlement of water to use in the expected manner. And for that reason, there was acceleration, perhaps, of discussions about storing Mexican water in the United States, in particular in Lake Mead. I show the bridge over by Hoover Dam over the Colorado River there. Lake Mead is a tremendous storage reservoir. So that I would call novel policy, adaptive policy, in this case to an urgent situation. And we always talk about not wanting to manage because of crisis. But in this case, I do see that there were some novel and adaptive tools that were implemented, or policies. And if you go to the next slide, and I should mention in minute 323, we've made use of the storage options by Mexico in joint sharing of shortages. And then novel approach is the Transboundary Aquifer Assessment Program, which has been mentioned. And that did take advantage of that minute 242. And so we've done novel things. So I think we have a good foundation. There always can be improvement, but that's my message. Thank you.
Thank you, Dr. McDowell. We'll move with Dr. Antonio.
Thank you. Yes, well, for sure we need some novel tools, and for sure climate change will play a key role in groundwater sustainability. As we can see here in the left graph, there's a precipitation forecasting model to 2000 to 2030. And according to several authors, precipitation is expected to decrease by 2% in 2030, related almost by climate change. In the meantime, temperature is also projected to increase by somehow 0.7 to 1.7 Celsius degrees. And also, as Chris perfectly pointed out in his presentation, annual runoff is also expected to decrease from 77% to 14% of the rainfall by 2050. So all this means that in the next, let's say, 10 to 30 years, vertical recharge will decrease, evapotranspiration will increase, and that will for sure limit groundwater availability only by climate change, again, mostly in the shallow aquifer. We need highly to fully understand the hydrodynamics of both aquifers. And you can see here, simultaneously, groundwater overdraft has been resulted in the last years. As you can see here, the pumping has been slightly increasing, especially in the 2000. And the bad news is right now we are taking water from the aquifer storage. That is not a good news. The best is that the aquifer can transmit only water from recharge zones, but not taking water from the storage. So groundwater pumping will also increase to sustain more irrigation, more domestic supply, and probably in the near future, more newly highly demanding water activities, such, for instance, fracking activities. Now, this government is not allowing fracking, but we don't know in the next probably 10 years will take place because we have a lot of huge shale plays. So groundwater overdraft will decrease, and also groundwater overdraft will probably decrease the surface water availability. For instance, we know that the Rio Bravo, Rio Grande base flow, we have a base flow from the clastic aquifer. So this will be
30 seconds left.
Yeah, the next one, please. The next one, no problem. Okay, so the key points of the question number 2 is that groundwater pumping in the transboundary aquifers has been increasing as water demands increase. No broad bilateral agreements exist on the US-Mexico groundwater management model until the 1944 treaty. And well, knowledge about the extent, depletion rates, and quality of transboundary aquifers is very limited in the Mexican side, or evenly completely absent. And this is basic for scientific diplomacy. And that's it. Thank you.
Thank you, Dr. Hernandez. And we move forward with the last question. The third question. What is the role of the water energy food nexus in transboundary waters? Mr. Soriano, please.
Thanks, Agustin. In the world, there are 263 transboundary river basins and 300 transboundary aquifers. More than 90% of the world's population lives in countries that are in the water resources about 40% of the world's population lives in transboundary basins and aquifers. Since 1948, there have been 37 conflicts on water. Although the number of transboundary water conflicts in the last 70 years can be seen as low, much work is needed in order to reach peacefully and operational agreements. There is in common knowledge in water diplomacy on the relevance to include the interests of multiple dimensions and actors. In this sense, to go beyond the water management approach, there is a growing need to recognize the interdependencies between water, energy, and food systems, where change in their demand, policies, and management have effects on the other systems and the environment. In this way, the water energy food nexus describes the complex and the interrelated nature of our global resource systems. The next one, please. The water energy food nexus is a systematic process for analysis for policy making to impact the interdependencies between water, energy, food, and other linked systems, for example, land, climate, environment, and ecosystem. Consider the synergies and trade-offs between water, energy, and food goes beyond the boundaries of the Transboundary River Basin. engage a greater diversity of the stakeholders, and can help to achieve more balanced agreements across these sectors. Enables a more coherent and integrated natural resource management, addressing the lack of cross-border agreements between countries, or to improve the management of the cross-border resources. Currently, few, or I would say that none, of the international agreements on water take into account these interdependencies between water, food, and energy. However, they have become more studied in the scientific literature, and they will be more important to address in the transboundary water conflicts. The final objective of the water energy food nexus in the transboundary water is to promote this intersectoral integration, sustainability, synergies, and efficiency in the use of the water resources. Thank you.
Okay, am I on? This is Sharon. Thank you. I didn't hear anything. And Elia, I am having trouble seeing the slide, so I'm assuming my first slide is up there. And I don't want to apologize, but if I need to, I will, that I didn't necessarily keep to the question here. I added something to it. And if you look at the upper right-hand corner, I say question 3, water, energy, food, climate, and I added people. And I could have added environment, because I really want to talk about a nexus or a nexi that we sometimes don't talk about. And there's a lot of people who work on the water, energy, food. I don't think I need to restate things that we all know about that. So I wanted to bring up that map, the lower basin portion of that map that I showed earlier. And I show Morelos Dam, which is the delivery point of much of the water to Mexico, at which point it is diverted to the west, and it serves an area outside the hydrologic boundary. That hatch mark isn't shown on this map, which was produced by the Bureau of Reclamation. So the water does not flow south to its natural terminus. And I think we know that. There's a lot of discussion about the lack of water flowing to the delta and the implications of the lack of that flow on nature. I will note on the photo to the right, which was borrowed from a borrower of a slide from Audubon, you can see that body of water is the Salton Sea that you see up in the top middle of there. So we need to think about the whole of all of these relationships. And so if you go to the next slide, I do have a slide here about the pulse flow. And the pulse flow was a policy, again, that was enabled by Minute 319. It again shows the novel and adaptive ability to do something different through the International Boundary and Water Commission. And so through a collaborative partnership, NGOs, the governments of the two countries, state entities got together to divert water or allow water to flow to the south and study the implications of that on the environment. And then on the right, I show a graphic with the link to a beautiful 10-minute video narrated by Robert Redford about the delivery of water and the pulse flow. I encourage you to watch it if you haven't seen it. It's beautiful, and about halfway through that is, I take that snapshot of the little girl playing in the water where it's usually dry and sandy. And so I want to make the point and take advantage of being able to make the point that water matters to our health in many, many different ways. And this beautiful photo of this little girl is why people, several years after I showed it at a conference abroad, people come up to me and say, "What a great talk you gave." I didn't give such a great talk. I showed the picture of that little girl. Thank you.
Thank you, Sharon. We'll go with Mr. Antonio.
Thank you, Agustin. I will focus to answer question number 3 in the water energy nexus solely. So such as aquifers in the study area, as we can see in the left figure, the Rio Bravo Basin, there are really huge transboundary shale plays. Basically, the Permian Basin, which is probably the largest shale play in the world with the Marcellus. It shares also with West Texas and Mexico, and the Eagle Ford Formation, which is correlated with other shale productive units. Not only the Eagle Ford, the Mexican Eagle Ford, but other ones such as the Pimienta Formation, the Buda Formation within the Sabinas and the Burgos region. So this transboundary framework of shale plays suppose a major management challenge from Mexico and the U.S. because this industry is very water consuming, as we know. We can see here in the upper right figure the water used to satisfy hydraulic fracturing procedures from 2009 to 2017. And as you can see here, for instance, the Permian Basin has been totally increasing their water use, and so on with other shale plays. Especially in the U.S., groundwater from deep aquifers represent the main water source for hydraulic fracturing in the Permian Basin and the Texas Eagle Ford Play. The question remains in Mexico: what will be the main water source for hydraulic fracturing if hydraulic fracturing will take place in Mexico? The shallow aquifer, the deep aquifer, because it will be groundwater for sure. In the lower figure, we can see that this is the water use per well in the Eagle Ford from 2009 to 2017, and as you can see clearly, the water use per well has been increasing over year and year and year. From less, let's say, the median value from 2011 was less than 20,000 cubic meters to frac one well. Today, we are recording from frac focus sources that water use per well is in the order of 40,000 cubic meters per well. I mean, that's a lot of water. We use 40 millions of liters to frac one single well. And if we are considering that the Texas Eagle Ford Play drilling rate is in the order of 3,000 to 4,000 new wells each year, that's a lot of water, right? We are assuming that the accumulated water volume to satisfy hydraulic fracturing procedures in the Texas Eagle Ford is in the order of 400 million cubic meters from the last 8-9 years. So if the same practices from the Texas will apply in Mexico, this largely will damage groundwater resources. We need to manage this in a better way. Next one, please. Well, to address this question, the key points are that, as reported by our colleague Eckstein in 2011, surface water, in fact, plays an important role for hydropower and energy generation in the Rio Grande Basin, but basically groundwater remained the main water source for shale play production across the basin. Energy generation by shale plays has been found to increase resilience on energy generation in Texas, especially during droughts where reservoir storage is depleted. And as we repeatedly said, water use for hydraulic fracturing has been increasing over time. This is a dangerous practice from groundwater resources. This increasing has been recorded in both single well water use per well and water intensity per horizontal length. Thank you.
Thank you very much, Dr. Hernandez. We'll go with the last question. This is about what are the key challenges when it comes to water security in the border region as a whole. We'll start with Julio.
Thank you, Agustin. There are many key challenges to consider in the water security of a transboundary region. First, from definition, the satisfaction at the host level of all the needs of water supply in adequate quantity and quality. Second, guarantee the capacity of the water bodies to maintain the environmental services, investing in water conservation, protecting their ecosystems, and using water more efficiently. Third, we need to establish methodologies that assess risk which takes in account the hydroclimatological and social conditions. Currently, there aren't instruments that regulate the use of groundwater in transboundary aquifers between Mexico and the United States. However, it's necessary to set and operate groundwater monitoring networks to support their sustainable management. Fifth, improve the governance, planning, management, allocation, and efficient use of the water resources. Water scarcity calls for increased integration and cooperation to ensure a sustainable, efficient, and equitable management of water. And the next one, please. Six, promoting tools to stakeholder to involvement to prevent conflicts where international organizations, governments, and local communities should play an important role. Seven, dealing with the present water scarcity and developing foresight to prevent undesirable trends. We need to innovate in policies and strategies to find a balance between the water for human and economic demands and the water for maintaining ecosystem and environmental integrity. 8, promoting and innovate tools for water supply and pollution control, developing and promotion of innovative tools that are needed to improve the supply of water in quantity and quality. Finally, the education for transboundary water cooperation and governance is important. Today, a few educative institutions around the world focus their programs on water negotiation for cooperation. We need to work at this point to improve the human capacities of the sector, of the water sector. Thank you very much, Agustin.
Thank you, Julio. Sharon, go ahead, please.
Yes, thank you very much. I got my slides back. So I'm good. You know, I had a very simple answer to this question. Actually, Julio, your list of not only the challenges but potential solutions was excellent and comprehensive. So thank you for doing that. The big challenge is what Chris Milley, I think, started off talking about, and that is we've got less surface water, at least in the Colorado River Basin, on the horizon, and we've got growing demands. We've got a tremendous imbalance between demand and supply, and we have to think about how we address that, and Julio gave some options and opportunities about addressing that. I talk a lot these days about the concept of wicked water problems. Wicked water problems are big problems that don't have a single solution. They require interdisciplinary looks at things, and it's not only the science, but it's also the people aspects. So the processes for stakeholder engagement and stakeholder input and study of the governance. There is a tremendous amount of study going on of governance at my institution, the University of Arizona, but many, many others. We have to talk to each other. The various scientists have to talk to each other. The scientists have to talk, the natural physical scientists have to talk with the social scientists. I did have one slide for this one, and it's to show that we are in a very, very challenging situation because of climate. In Tucson, where I live, we set very unhappy records this summer. We had the lowest rainfall on record for our summer monsoon, second lowest rainfall on record for our summer monsoon season, about 25% of normal. We have set and broken the highest number of 100 Fahrenheit degree days or warmer. The previous record was 99. Not only did we hit 100 degree days, but we hit 108. And I think yesterday's high here was either 99 degrees or 100 degrees. We're getting hotter precipitation patterns. That is the big challenge that we have to adapt and deal with this imbalance of supply and demand. The chart on the right shows a chart that was shown just a few weeks ago to the Central Arizona Project Board of Directors, and it shows the flows into Lake Powell, the inflows. Those are those upper basin flows that Chris talked about. And look at how terrible it is by those orange bars compared to the average, the blue. the average on record, and look at the number for August was minus like 4%. These numbers are very bad, which means shortage of water in the Colorado River system and cutbacks. And that affects Mexico as well because of Minute 323 and the agreement to share certain shortages if they get bad enough. Thank you.
Thank you, Dr. McDowell. Then we'll finalize with Dr. Hernandez.
Thank you, Agustin. Well, as perfectly Sharon explained, there's not a good formula for achieving water security because we have very little surface water, and groundwater is also compromised to achieve irrigation and domestic supply. But probably the main limitation to achieve water security, talking about quantity and quality for all, within protecting our environment policy and social peace, is the inequitable water availability and accessibility. As you can see here in the left figure, we have several different water withdrawal rates along the basin, and this is very difficult to handle. In the meantime, there is a clear, as you can see in the right graph, there is a clear increase in population, an increase in water demands to satisfy different users, mainly irrigation. Irrigation stays for mostly 75–80% of the total water withdrawals, and that is mainly relying 100% in groundwater. So this combination of very little surface water, new groundwater users, it's going to be very difficult to achieve water security. So we need to handle a better management model for groundwater resources, particularly in the region. Next one, please. So basically, we are talking about novel hydrodiplomacy tools and water diplomacy, but the main aspect of the Mexican water management model is that we are ignoring some simple and basic aspects. For instance, we are managing water using management boundaries instead of using groundwater flow systems or geological boundaries. This is, I mean, we are using in virtual boundaries instead of using the real geological boundaries of the system. We are ignoring connectivity between shallow, deep, and surface water and transboundariness. Again, as I stated before, the National Groundwater Commission considered that for instance, the Allende Piedras Negras aquifer is a big deposit, but there are several groundwater flow systems that need to handle differently in terms of management models. In Mexico, we have a very limited access to open data, and this is quite difficult to handle throughout Mexico, not only in the basin. There is lack of basic groundwater open data, for instance, water levels, overall quality, abstraction rates, hydraulic parameters, and this highly limits the assessment of regional time-space aquifer resources and also the water security aspects that we're talking about in these questions. And in fact, severe droughts also prevent the U.S.-Mexican treaty compliance and increase groundwater stress in the basin, which will be complicated to address in the near future. Thank you, Agustin.
Thank you. So we'll go to the Q&A session. We have still quite a bit of time. We were supposed to end the panel session at 11:40. So we have 5 more minutes for questions in addition to the 20 minutes of questions. So
no, you still have the 20 minutes for question, Agustin. You're good. You're good.
It might be.
Okay. So I will start. There are some specific questions to some of the panelists, and there are also general questions. So I will start.
Agustin.
Yes.
So I was collecting some of the questions. The questions I already posted again on the chat. So I put them together.
Yes.
And I've been sending some questions to Julio, Sharon, and Antonio. So because we have more than 14 questions.
Yes.
So I don't know, I think our panelists may be able to pick one or two and go with it. Just for the panelists, could you mention the name of the person who posted the question? It is at the beginning of the question. I put the name in there.
Sam, if you don't mind, with Augustine, I think it might be easier if he selects the questions and reads them and directs them to us. It's a little hard to listen and read and do all that at the same time. Is that okay, Augustine?
Yes.
And the other panelists?
That's fine for me.
I agree, sir.
Thank you.
Okay, so I will start with a question, specific question for Dr. Sharon. This is from Luzma Nava. She's asking, what is missing in the Rio GrandeBasin to further advance by national stakeholders cooperation, as in the Colorado Basin side? What is preventing them to collaborate further?
Okay, that's a great question. And Luzma, it's nice to, I'll have to look at your picture. We sometimes connect through ResearchGate, I believe, with some articles, I think. But I can't speak as well to what is not happening in the Rio Grande, because as I indicated, I'm not an expert and intimately involved with that. But I think I can speak to what is happening in the Colorado River Basin. And here I'd like to actually speak to what's happened in the Colorado River Basin on surface water, which is much more robust than anything related to groundwater, because we really have just started that effort. And while we've made our team, our Transboundary Aquifer Assessment team, has made great strides, we don't have the systems in place that they do for working on the Colorado River transboundary surface water issues. And there have been great strides made in the last decade or so. And so I want people to be encouraged. Let's try to focus on the positive and the opportunity to implement solutions. And they can take time, but I will tell you, just in maybe 12 to 15 years, there's been tremendous strides and tremendous progress by opening up the conversations and allowing people to voice their viewpoints in early phases of the discussions. And this includes environmental NGOs. It includes having more exchange of information between the countries at forums like Colorado River Water Users Association, which is canceled this year. But I want to tell you, I sat in a room, I don't know, 12 years ago or more, when there was a panel on the dais speaking about water in Mexico and the deliveries to Mexico, and there was not a Mexican official on that panel. And I was sitting next to the former SELA commissioner, the late Arturo Herrera, and he wasn't even given time to ask a question. It was disrespectful. That has changed significantly. And so I think looking for opportunities to allow people to engage. They understand they're not the decision makers, but to provide input. And I just think that that's extremely, extremely important to getting us on the same page so that we understand why policy actions are taken.
Thank you, Sharon. We have a specific question now for Mr. Julio Soriano from Joel Carrillo. He's asking regarding water security, how the capacity of people to solve groundwater issues is to be tackled. Julio?
Thank you, Agustin. I prefer to respond to the question in Spanish in order to, digamos, collaborate with the binational of this panel. Muchas gracias a todos. Con respecto de la última pregunta sobre cómo podemos abordar estos temas de seguridad hídrica, pues creo que como lo puse en mi presentación o como lo abordé en la parte de la presentación, se trata de caminar en primer lugar sobre la concientización, el abordar, digamos, que todos los tomadores de decisiones puedan tomar parte de ellas como tal, y no solamente lo que son las organizaciones civiles o la academia, sino conocer en viva voz o en propia voz quiénes son, digamos, quiénes son los principales, digamos, interventores o los que están, digamos, viviendo la problemática en el sitio. En este sentido, la primera, digamos, parte es este proceso de concientización de información, de transmitir información de calidad de manera abierta para que todos puedan tomar parte o formar un criterio que les permita llevar a cabo, pues digamos, tomar decisiones oportunas. Y en este sentido, como lo mencioné también, pues se trata de mejorar nuestras herramientas, digamos, de modelado, así como de digamos, de análisis para poder realizar, pues digamos, de alguna manera estudios o, ¿cómo decirlo? Digamos, análisis o conocer el estatus actual de manera más efectiva. Esto nos permitirá llevar a cabo, pues, digamos, transceder hacia digamos, hacia decisiones más oportunas en ese sentido. Muchas gracias. No sé si puede responder la pregunta.
Thank you, Julio. We have now a specific question for Antonio Hernandez from Alfonso Rivera. He's saying, given the nature of some of the alluvial and confined karstic aquifers located along the Rio Grande Basin, would you say that climate change impacts groundwater availability only in the alluvial aquifer and not the confined aquifer? In that case, how does this translate in sharing the transboundary groundwater in those aquifers?
Great. I will also answer in Spanish if you agree, so I will change my language here.
Good.
Ok. Ya lo cambié. Alfonso Rivera, un gusto escucharte a distancia. Saludos para ti, para la familia. Pues es una extraordinaria pregunta, es la pregunta. Yo creo que esa no está muy bien respondida y no la puedo responder, ojalá la pudiera responder. Yo creo que no es que los acuíferos someros libres sean los únicos que estén afectados por cambio climático. Definitivamente yo creo que también los acuíferos profundos confinados van a estar afectados por cambio climático. Pero yo creo que sí los acuíferos libres de la formación Sabina Reynosa, de los conglomerados, de los aluviones, van a ser más propensos a los cambios climáticos porque el nivel freático es muy somero, menos de 10 metros en ciertas áreas, hay manantialismo conforme nos vamos acercando al río Bravo, conforme nos acercamos al río Bravo los niveles se hacen muy someros, el acuífero es muy permeable, muy transmisivo y eso va a ocasionar definitivamente que si tenemos una época prolongada de secas, si decrece la precipitación, si aumenta la evapotranspiración, como los modelos de cambio climático han predicho en la zona, pues eso definitivamente va a limitar la recarga. La pregunta sería, ¿qué tanta conexión hidráulica hay entre los dos sistemas de flujo o entre los dos acuíferos para poder determinar si los acuíferos profundos también serán propensos a cambios de disminución de recarga? Esa es una pregunta muy buena. Yo me atrevería a decir que tal vez es un poco difícil en ciertas áreas, porque si te pones a pensar, la estratigrafía está formada por una serie de acuitardos limoarcillosos, margas, 10, 12 formaciones geológicas, la Buda, la Austin, la Eagle Ford, que eventualmente, geológicamente, al menos sí aíslan el paquete aluvial de arriba con el confinado de abajo, pero definitivamente creo que es algo que tenemos que analizar y estudiar a fondo. La propia Rosario ha estudiado mucho la parte transfronteriza y tal vez tenga algo que decirnos al respecto, pero creo, respondiendo de manera concreta a tu pregunta, que también los acuíferos confinados van a estar afectados por cambio climático, pero no tanto como los acuíferos más someros. Espero haber respondido tu pregunta. Gracias.
Gracias.
Thank you, Antonio. And now we'll go with general questions. There's a very good one from David Guevara. He's asking, the 1944 treaty does not consider groundwater in the allocation of water between the US and Mexico. With the rising tensions between both countries, can we expect that they will be included in future negotiations? Maybe we can, each one of the panelists can talk a bit about it. Who wants to start?
I'll go first. I'll be
Sure,
great.
okay.
It's a tough question. I guess I'll be true to form in that I have a question about the question, because it's in a sense saying in future negotiations, and I guess the question would be negotiations about what? In that we have regular negotiations relating to Colorado River surface water supplies. There are obviously issues. I mean, there's the hot topic of the October 24th deadline coming up on deliveries from Mexico to the US in the Rio Grande Basin. Elia Tapia, who's on the program and part of this whole transboundary effort, finished her PhD this summer, and one of her chapters has to do with what to do, what kind of framework could we look at for binational management of groundwater. And I'd say that there are different opinions as to this, and some people think that the 1944 treaty is sufficient, and what it really is going to take is localized efforts to look at the groundwater situation and come up with proposals to then see how you can implement. Because aquifers tend to be more localized than surface water supplies, you really have to look at the individual circumstances. That's why the Transboundary Aquifer Assessment Program has potential to aid the understanding of the characteristics of the aquifers, so we can get on the same page, know what we have in order to talk about management. You can't talk about management of an invisible resource without knowing what the conditions are. So I think we have a lot of steps to go through and a lot of discussions, and I would say it might be really interesting if a region could come up with a proposal and see if it could be implemented under the current framework, or if there has to be a negotiation on something other than that. And I would say it gets very, very complicated because of involvement of the states. The federal government necessarily have to be involved, but in the US, the states have a lot of authority over groundwater, and there are different approaches to groundwater management within US states. So it's complicated. Maybe we need to have a step forward pilot come in and say, hey, we want to do this. Can we do it? And if not, what needs to change to enable us to do it?
Thank you, Sharon. Anyone from the Mexican Fellows who would like to add something? No? Can I? From Rob Boss, he's saying to augment water supplies in the Colorado River Basin, are there plans to investigate binational desalination in the Sea of Cortez or the Pacific Ocean? Who wants to answer the question?
I'm again happy to do that because I know about it. But if somebody else wants to answer, I don't want to hog up the answering here.
No, go ahead.
Go for it, Sharon.
Go for it. Now the question is, are there efforts? Again, this is part of Minute 323. There are provisions in Minute 323 for binational study of desalination. And in fact, there has been an ongoing effort to look at desalination in the Sea of Cortez. A report has been submitted to IBWC, and perhaps somebody from there could provide a link in the chat to where that report is. And I personally haven't had a chance to look at the report yet, although I've heard a report on the report. But I do want to, again, take advantage of the microphone here and point out the importance of sharing lessons learned. And I actually organized a panel in Tel Aviv for a conference there where I brought over principals involved in this binational study of desalination in the Sea of Cortez to talk about the role of technology in a binational setting and looking at the situation over in there with Israel and Jordan and possible desalination, joint desalination efforts in the Red Sea. So these are, again, important efforts, and they are ongoing. And I think talking about all the desalination efforts that have been talked about is beyond the scope of this answer. But again, it points to the cooperation, and there's, in my view, maybe I'm a Pollyanna, you know, looking at the bright side, but there's tremendous cooperation going on water issues. These are tough issues. So it takes a lot of work to get to solutions that can be implemented, but desalination is certainly one of the options being examined.
Thank you, Sharon. Now we'll go with the next one. Again, it's from Alfonso Rivera. He's saying Mexican administrative aquifers are only applied within the borders of Mexico. They're national. So what would you recommend to do in the case of transboundary aquifers shared with the US? I don't know, maybe Antonio can answer that question.
Yes, I will speak in Spanish again. Sí, Alfonso, pues muy buena pregunta. Yo creo que los modelos hidrogeológicos de gestión en las zonas de frontera tienen que considerar aspectos transfronterizos definitivamente. No podemos seguir considerando un modelo de gestión meramente nacional en el que pensamos que el agua subterránea llega a la frontera y se detiene automáticamente porque no tiene pasaporte o visa. Yo creo que el agua subterránea tiene que considerar un modelo mucho más anticipado de gestión integrada transfronteriza y tiene que considerar estos niveles acuíferos de los que he hablado, los tipos de flujo y tiene que considerar también aspectos en común. Por ejemplo, si Estados Unidos maneja límites geológicos y nosotros administrativos, si Estados Unidos tiene repositorios abiertos en Internet y para nosotros sigue siendo confidencial y secrecía poder manejar los niveles piezométricos, va a ser muy difícil que podamos manejar los recursos transfronterizos de una manera adecuada si solo estamos viendo una pequeñita parte de la película. Yo creo que tenemos que revisar los tratados internacionales y tenemos que, particularmente para los acuíferos transfronterizos, trabajar mucho con nuestros vecinos y generar nuevos modelos, nuevos entendimientos de gestión y darles usos similares, ¿no? Por ejemplo, si en Estados Unidos, en Texas, está utilizando el agua profunda de los acuíferos salinos o subsalinos para satisfacer actividades de fracturamiento hidráulico, esa pudiese ser eventualmente una buena política en México, porque si se tocan los acuíferos que ya están comprometidos para satisfacer irrigación, consumo humano, otras industrias, pues vamos a generar un nivel de estrés hídrico bastante preocupante en la región.
Muchas gracias, Toño. Yo también coincido con tus comentarios. Es importante que trascendamos hacia esta delimitación basada en la parte geológica y que podamos tener esta especie de colaboración con todos nuestros, compañeros y, colaboradores en Estados Unidos a efecto de tener un mayor entendimiento. También, incluso como tú también lo refieres, a través de la Comisión Nacional del Agua, muchos de estos, mucha de esta información no está libre o accesible para todos. Entonces tenemos que trabajar, como también lo mencioné en mi presentación, sobre esta manera de poder brindar información libre y accesible a todos para que puedan realizar su propio o formar su propio criterio en orden de, realizar estos análisis. Yo creo que, debemos transitar sobre estos puntos. Muchísimas gracias.
Thank you for your answers. Then we'll go with the final question by Dr. Adrián Pedroso. Okay. He's saying, we have been discussing constraints related to climate change and its effects on water, both surface and groundwater. But what about the need for water for economic activities that occurs in both sides of the border? Is it desirable to open the discussion as well on the differences on the framework that we currently use to define water rights? Who wants to say something? Sharon, perhaps?
A very, very important question on the definition of water rights and then monitoring what is done per those water rights. So, in Arizona, we say that the water is, groundwater is owned by the state and not by individual landowners, yet the rights to use groundwater are almost like ownership rights and property rights. And I'm going to come back to the maybe Alfonso's last question and what we've talked about already a little, and James Caligari will be on a panel tomorrow talking about some of the studies. But the whole idea of transboundary aquifer assessment is trying to figure out just what is going on. And so, as I understand it, in Mexico, you've got these concessions and these legal rights to use groundwater, but it's not clear to me but that the actual groundwater use is being reported. And so maybe that's why you have to do the GRACE imagery and look at some of the work, that's already been talked about today to know about this. So changing water rights is very, very difficult. It's very difficult in the United States. But what we've seen is that if people understand the circumstances of their aquifers, and to Alfonso's question, that's part of what the Transboundary Aquifer Assessment is trying to do, is look at the aquifer as a transboundary aquifer. And yes, there are administrative units on Mexico, and there might be management areas on the US side, but let's take a look at it as a whole and model it and understand it. Unfortunately, there's not been consistent funding to do the kind of modeling that people would like to see done. But I think before you talk about changing or redefining water rights, you've got to talk about what's the situation, what are the opportunities, options, and then what could make them happen. And sometimes it's a matter of opening up a market, a transaction mechanism, not changing the fundamental water rights. So it goes to this issue of the hard work that needs to be done. And there are examples of cases where it's been successfully accomplished, where people decide to possibly tax themselves, to market within themselves, to improve the groundwater situation for all of us, because for the users in the area, it's a common pool resource.
Thank you, Sharon. Anyone else? Julio or Antonio? No? Then I think we have we're very short of time. We'll have we'll go straight to the wrap up from this session. Many topics were addressed in this by these three panelists from different perspectives. Of course, the first question was related to climate and hydrology in both transboundary basins, and I think there is the most of the three panelists, they concur that there is a decline in terrestrial water storage and overall water availability in both basins. The Rio Grande has been less resilient to the 2011-2012 drought than when compared to how climate variability has affected the Colorado River Basin. Of course, each basin has different groundwater systems, and shallow aquifers tend to be more sensitive to climate variability than deep aquifers. About the need of having or the implementing new hydro diplomacy tools, there is the consensus that all the solutions must be backed by science and research. Also, there is one of the panelists suggested that perhaps it would be perhaps the authorities need to consider including new groundwater minutes in the International Water Treaty, and of course it's worth that again the authorities and river basin councils, they envisage the replications of innovative projects such as the Transboundary Aquifer Assessment Program that has been held in Arizona for already quite a few years. Perhaps doing something similar in the Rio Grande could be worth. And then finally, the interaction between water, energy, and food. It's a very complex question. Then some of the solutions proposed by these panelists include cross-sectorial integration, synergies, and resource use efficiency. Of course, we need to be aware with other important users of water, such as the conventional shale resources. This is the fracking industry. Again, the water availability in some of these regions are limited, and there is if they're not properly addressed, there's an efficient use of water. This can lead to a potential generation of conflicts among users and, of course, among both countries. With that, I will ending up this session. I will leave you now with Sam and Rosario. I see there's Mr. Valente Sousa who would like to. He made a statement that I will read that is related to the question, I think, to Sharon McDowell. He's saying, in order to understand the basin of the Colorado River Basin, a watershed vision must be included beyond national borders. It is a territorial management strategy, and that includes a basin management master plan that comprises grasslands, geology, and underground geology, forests that are adequate to the region, and the issue is to decrease the temperature of the soil to promote rainfall. Without percolation, the aquifers will always diminish. Thank you for your contribution, Mr. Sousa. So I will leave you now with Sam and Rosario. Thank you very much. Thank you for your participation, and I hope to see you in the coming panels and keynotes. Bye.
Thank you, Agustin. Thank you, Sharon, Julio, Antonio. This was pretty good panel. Pretty deep. Too many notes. We're learning too much in very short time. But thank you. So we're going to move forward now to our next
Okay, Rosario,
yes?
can we just give a minute to Valente? Valente, are you still there?
Yes.
Can you share
thank you.
A minute
thank
of
you.
your thoughts?
Thank you so much. Thank you, Sharon McDowell and Antonio Hernandez.
Valente, are you talking English or Spanish? Please select
English.
the language that you would like to use.
Where do I do that?
At the bottom, it should be.
At the bottom, where there says interpretation, please select the language that you will be using.
Oh, I'm sorry. I am sorry. Yeah, it was in English. Thank you, Sharon and Antonio Hernandez for discussing these issues. Where I come from, I have a company that does master plans, regional master plans. So if we don't close the hydrological cycle, I understand that hydrogeologists say, well, the volume and the time it takes for the aquifer to replenish is very long. Yes, but we haven't been taking care of it. We have grasslands, we have forests, we have the fractures of the rocks, and if we don't lower the temperature of the soil, the big source of water, which is the clouds, will always evaporate before they reach the place. So we have to have the basin, complete basin system, lower the temperatures in order to incorporate in the balance of water, which I don't like balances, no, as a concept. But we need to increase the huge amount of tons of water that the rainfall provides into the aquifer. It's very important, because otherwise it's only, we are fragmenting the knowledge and the science of understanding the aquifers. You understand perfectly what I'm talking about, so I don't want to expose more.
Thanks, Valente.
I'm delighted. Thank you.
Thank you. Yes, it's very complex, and sometimes to understand it, we fracture it, and then the knowledge gets fractured at the same time, and then we are unable to put it back together as a puzzle. If you don't mind, muting,
precisely.
Muting your microphones.
Yeah, okay.
Oh, I didn't mean him, but
when I do master plans, I incorporate Joel Carrillo. I don't have the pleasure of knowing you, Antonio. Biologists, Forrest, like Teobaldo Aguiluz. I mean, I have a smorgasbord of life sciences that are incorporated into designing these master plans. And from many points of view that you start to understand, my point is either you talk to the earth and I'm not being Pachamama about it, no? Either you talk to the earth and you transmit that very, very complex information into databases that you can cross with your mind, not only with computer models, no? Otherwise, this conversation has been going on forever. When Santiago Creel was the Minister of the Interior, there was this same issue in 2003. He said, if you don't have a conversation of the basin, it's a useless conversation. It's not my water or your water. It's like in Mexicali, you know, that we're sending from the wastewater treatment plants to the Imperial Valley, and then they sell us tomatoes. They're absolutely right. And we are dumbasses not to use that water, treated water in our lands, and then percolate our aquifers. Because we're just, if it's a balance issue, we will always lose water. It's impossible to balance it. And that's desalinization projects, which are, okay, I'm terrified that you will increase the salinity because of the purge of the concentrations into the Sea of Cortez. I mean, it's not technology, it's understanding the basin.
Thanks, Valente.
Thank you, Valente.
We need to move on, but thanks.
Thank you.
Okay, so we're going to move with our network break presentation. We have a very interesting presentation right now. It's going to talk about funding, or ideally, that's what I'm looking forward, funding opportunities for transboundary aquifers between Mexico and the U.S. And I'm going to introduce our speaker. Fernando Barrera has worked at the North American Development Bank over the last 10 years. Since August 2019, he has served as Associate Director of Financial Services, Corporate and Public Sectors. His functions include the development, coordination of due diligence, closing and disbursement of credit in public and public-private projects, both in Mexico and the United States. Previous to this position, he managed for over a year the Border Environmental Infrastructure Fund. Mr. Barrera has 25 years of professional experience in the positions of cost specialist, economic engineering, and contracting under the Corporate Department of Engineering and Project Development at Pemex, as project manager under the U.S.-Mexico Border Affairs Office at the Mexican Water Commission, and as an engineering consultant at FE Asesores SADCB. He holds a degree in civil engineering from UNAM and has a master's degree in project planning and management from the University of Bradford in the United Kingdom. Dr. Barrera, please go ahead if you are there and
Yes.
Start your presentation. Thank you, Fernando.
Thank you, Rosario. Just clarifying, I am not a doctor. my highest degree is a Master's of Science. You're going to be passing the presentation, right?
Yes, we are, and it's already there for you.
Yeah, okay. Thank you very much for inviting NatBank to review what we do in the border. Certainly, water is a very important sector. It's one of our core sectors within the bank. When it was created, we started like doing a lot of water projects, and it is still like at the core of our operations to promote like the implementation of these projects in the border. And next, Rosario, please. So a little bit of history. The bank was established parallel to the formalization of the North American Free Trade Agreement back in 1994, along with the Border Environment Cooperation Commission, with which we merged in November 2017. And our mandate is to develop and finance environmental infrastructure along the US-Mexico border. This means like 100 kilometers from the borderline north in the USA and 300 kilometers out of the border. We do this by providing loans and grants for their implementation, and also we offer funding on technical assistance for project development. We are governed by a board of directors, which is part from the government of the United States and part from Mexico, and we are located our offices are located in San Antonio, Texas, and Ciudad Juarez, Chihuahua. We are AA1 Moody's rated and AA Fitch. Next. So as I was telling you, we have 10 members in our board of directors, 5 on each side. From the US, we have the Secretary of the Treasury, Secretary of State, and the Environmental Protection Agency. And their counterparts in Mexico, Secretaría de Hacienda, Secretaría de Relaciones Exteriores, and Semernet. We have also a U.S. border state representative in the U.S., which is a senator of Texas, and also a public representative, which was a former senator locally in California, Denise Duchenne. And in Mexico, we have also those 2 representatives. Mexican border state representative is like the Unidad Coordinadora de Entidades Federativas, which sees like all the affairs related to entities and municipalities in Mexico on their issuances. And on the public side, we have Carlos de la Parra from the COLEF. Next. So within our region, here we are graphically showing our region. Roughly we have, along our history, financed 41 projects in the US, benefiting a population of around 6.3 million people. And in Mexico, we have benefited with our projects more than 220 municipalities with a population estimated at 16.4. So we are overall talking about 261 projects benefiting more than 22 million people in the border. Next. These are the eligible sectors that we can participate on with all of our programs, which we will see in a while. The first 2 are like our core sectors and were the ones for which the bank was originally created, but with the time we were incorporating additional sectors. So water and sewage, that includes water supply, treatment and distribution, wastewater collection, treatment and reuse, water conservation, and storm drainage and flood control. On the side of waste, we finance sanitary landfills, collection and disposal equipment, closure of dump sites, recycling, site remediation, and toxic waste disposal. Air quality, we have done quite a few projects on paving and roadway improvements, ports of entry, public transportation, and industrial emissions control and reduction. A big part of our portfolio is related to renewables, mainly solar and wind in both sides of the border, biofuels, biogas and methane capture, hydroelectric, geothermal, and energy efficiency. We finance public lighting, building retrofits, equipment replacement, and efficiency in water utilities. So as I was mentioning, we do this through the following services. One of the important aspects of the bank is that we review and verify the technical and financial viability of the projects, as well as their sustainability and environmental and health impacts, through a process that ensures transparency and public participation. As part of our approval process, we make available to the public a document that describes very transparently the details of the projects that we are participating in. In terms of the products that we offer loans up to 30 years with very competitive rates. We include, as part of these financial services as well, technical support in several ways, like financial services or technical assistance, due diligence, coordination, and project structuring services. In November last year, our board of directors approved like a temporary 2-year financing program to support the communities dealing with the economic, health, and social impacts of the pandemic, while at the same time promoting what is core to the operations of the bank, the environmental improvement in the border region. On the grant side, we have our community assistance program where we can fund through grants up to $500,000 amount for public sector projects in low-income communities in all sectors, but with a priority to our cores. The Border Environmental Infrastructure Fund, which is funds appropriated by EPA that which are administered by NatBank and are available for water and wastewater projects within 100 kilometers of both sides of the border. And technical assistance, which includes grants and technical expertise for developing environmental infrastructure projects and exploring emerging sectors. We also offer through seminars and workshops institutional capacity building, addressing emerging issues such as climate change, green infrastructure, and public transportation. So through these programs, we could support these transboundary aquifers analysis efforts. Next. The value that it's added by the participation of NatBank in the financing of a project is that we have what I just referred to, the certification and financing process, which includes like a technical and financial review with the support of our specialists on structuring to the best financing structure for a specific project tailor-made, the financial structure of the project. We are transparent and we have this process that I just talked about public access to our projects. We oversight procurement and construction, and we measure the results of the project we invest in. In terms of the institutional strengthening to institutions, we provide access to technical assistance and training programs, and we have a hands-on project facilitation. We are a partner in project development, streamlining interaction between our project sponsors and relevant public authorities. In terms of supporting public policy, we also develop strategic planning studies to enhance sector opportunities. And we provide affordable financing packages with what I mentioned, competitive rates, long-term loans, tailored to specific needs of community and project, and we could build up a blended grant and loan package to make a project happen. This is kind of a summary as of June 30th, 2020 of what we have financed. We have 5 new projects certified, 3 of them on our core sector of water and wastewater, one energy efficiency project, and 1 public transportation for a total investment of $58.4 million, of which NatBank participation is just above $40 million. Of this amount, 31.1 million is in the form of a loan for 2 projects and 8.9 million in grants for 3 projects. The population we benefited with this project is 644,722 people in the border. In terms of our activity in 2020 for technical assistance, we had 5 studies in process with a total grant commitment just below 700K. We implemented 1 model for the basic utility management program completed with 27 participants representing 22 water utilities of the border. Through PDAP, which is also funded with EPA appropriations, we have ongoing studies, 11 ongoing studies on worth 1.8 million of grants to support the development of water and wastewater projects that are going to be receiving like BIF subsidies. And in terms of the border 2020 program, we have also 2 environmental and health initiatives underway with grants totaling $735,585.
Fernando, we have just 1 minute left.
Well, this is a summary of where we have invested, just to break down what I have just already explained. 267 projects with a total investment of 10.1 million as of June 30th, 2020. Next, Rosario. And this is kind of how our portfolio is structured on these projects. 154 projects, mainly on water and wastewater, consistent with the fact that this is like a core sector, and obviously groundwater transboundary efforts fall within the interest and initiatives that would be very interested bank to participate in. Next. In terms of investment, community financing, we have invested we have a 3.3 billion contracted to support these projects. 2.5 billion are in loans and 0.8 billion in grants. And this is how they are split: 29.1 in wind energy, 20.1 in solar energy, 30.8 on water and wastewater. So up to a third of our financing has gone to this sector. That's pretty much it. I don't think.
Thank you, Fernando, very much. And now we're going to open a little bit the room for people that wants to ask questions.
Yeah, we have one question from Alicia Ravello. Hi. Could you tell us which projects are currently financed in Baja California?
In Baja California, we are investing through BEEF on the rehabilitation of some sewage collectors in the river zone in Baja California. We have been very active on doing that. And we have been involved in also on the loan side. We are, this is not yet to started, but we have done also like a bunch of technical assistance trying to participate in the solution for the Tijuana River issues. And that's pretty much what we are financing right now in Tijuana, you said, or Baja California? Because we also
Baja
have
California.
in Mexicali, we also have some rehabilitation of wastewater infrastructure ongoing. That's what we have as far as I recall right now.
So perhaps here a couple of, well, one comment for later. Perhaps you can send us the link, or where can we find some of the current projects in the NatBank. And then the second one, I think for this community. So the NatBank works 100 kilometers north and 300 kilometers south in all the projects that you were mentioning. So how can this community of academics, researchers, some people from the government agency, so how can we, who should we partner? How can we get together? Who should we get together so they can see if there are any projects that they can apply, and what type of projects?
Yes, well, our website provides like very good information on what we have participated historically and what our phase is. I invite you to surf our website. There is a bunch of information. As a public organization, we try to keep very transparent, and all the available information of these projects that I have just discussed here, it's pretty much there. If we are talking about new developments, you can directly contact me, and we'll evaluate internally how to channel any effort on the matter.
Fernando, can I jump in, Sam, on this?
Yes.
Do you, are you aware of any funding that actually has happened from NatBank to do research on collecting data on transboundary aquifers or for transboundary aquifers?
Not that I can recall. Not that I can recall. As a sectoral study, from the top of my head, I cannot. I can dig into that, Rosario, and confirm that to you. But regardless, I mean, as I mentioned, we are very interested in these sectorial projects or initiatives, and we could explore like an initiative in this matter going forward.
Do you think that's possible? I mean, would it fit under the NatBank kind of categories of funding?
Oh yeah, yeah. I think we could. I mean, if we, I mean, as I mentioned, water, all related aspects of water conservation, and I think within this category, this could fall like very, very straight into it. We could analyze an initiative to participate on this, and because it's on the border, I think it would be of the most interest.
We have two questions. One from Luis.
Sam, if you can move towards your screen so we can hear you, because we can't hear you.
Oh, sorry. So we have two questions. One from Luis Garnica. Is the bank mainly focused on infrastructure projects? Does it finance any research efforts?
Yeah, we are, as I show the numbers, we fund ourselves. We go to the markets to fund ourselves, and with the proceeds of our loans, we fund our subsidy programs. So we basically invest in projects, in infrastructure projects, to generate the subsidies. We have our Border to the program that I mentioned, Border 2020, that could provide funding for this kind of assistance, and that subsidy from EPA. So I think that could be also a way to explore to go through these initiatives. But responding, yes, we are an infrastructure bank, and that's within our mandate. We need to implement projects for improving the well-being of the border communities.
We have another question from Gilbert Anaya. Do the various sectors within the NatBank, water, wastewater, energy, do they compete against each other? Is the water, wastewater still the priority for NatBank?
Yes, it is. Yes, it is. And but we, as I mentioned, I mean, our experience has shown and that grant resources are very limited. It's not very easy, particularly in Mexico, and I'm going to talk about Mexico. Our participation on the loan side has been complicated because of the constraints that the financing legal framework entails for local communities. But it is still like a core sector. I would say that we are very focused on that, but as a bank that needs to generate this income to increase like the grant programs, we also need to seek for the cash generating projects, and that's why we have like a big chunk. I mean, as I mentioned, we fund ourselves in the markets. We need to pay for the loans that we provide, and that's why we take very seriously like the technical and financial feasibility of a project that we are going to be paid back, so we do not risk like the participation of the bank in these initiatives.
Okay, we are right on time. Let me just put one last question. Okay, so well, actually we have one super quick, and that one is from Alicia Ravelo. That will be, does the NatBank finance projects related to water harvest, rainwater harvest in arid zones?
We could certainly do it. We have been investing also some resources in what we call like green infrastructure in the past. specifically in Arizona, and I believe that yes, we could provide financing through grants or loans on that.
Yeah, and last one for this round is from Alan Valle. Is taking in consideration the economic model predominant in the U.S.-Mexico free market. What quantitative arguments are utilized to?
Sorry, can you repeat
what quantitative arguments are used for investing in infrastructure between the two countries? Do you use any quantitative measurements to define where you're going to invest, considering the free market between Mexico and the U.S.?
Not necessarily. I mean, we are kind of market driven, and we respond also to the requirements, specific requirements. Something that it's like utmost important now for the bank, as it has been in the past. It's like all the water issues that are occurring on the border, like wastewater control and addressing spillages in the border. So that's a high priority, regardless of any other kind of consideration. I would say that we respond to how we are asked to participate into projects.
Mm-hmm. So perhaps in that one, the message is that you have a broad agenda, or you have, at least in the water sector, there might be many opportunities. So please partner and get close.
Yeah, and I would say that in the public side, we keep like a very close relationship with all the border actors. So we are kind of aware of what is going on the border communities, because we have been there like for a long time. And I mean, but regardless, as I said, if there is an opportunity or something that falls within our eligibility criteria that you think we can participate in, we are more than happy to analyze the project or how the bank could participate into these initiatives.
Yeah. Gabi, could you go back to put Fernando's contact info? So I think related to that, Fernando, is that if anyone thinks that there is something that might be suitable for NatBan or financing for NatBan, please contact Fernando. And I think we have to move on. What is next? Thanks, Fernando. Muchas gracias.
Thank you, Fernando. Thank you, Sam.
No, thank you for inviting us.
We will definitely follow you.
Okay.
Now that you've been here, now you're going to be chased by this group pretty soon.
More than happy.
Thank you. Okay, so our last session for this morning or afternoon, our theme lecture, The Human Right to Water in a Transboundary Context. We have two speakers, 15 minutes each. The first one is Carolina Escobar Neira. She holds a bachelor's degree in psychology, a master's degree in environmental psychology, and a PhD in social science research. She has extensive experience working with populations in vulnerability situation and on issues related to human rights, governance, and sustainable use of water, environmental education, and community management of commons. She's currently the Deputy Coordinator of Social Participation of the Mexican Institute of Water Technology, IMTA. Dr. Carolina, please, if you are there, which you are, I already see you, please take over. Your presentation is ready. You have 15 minutes.
Gracias, buenas tardes a todas y a todos. Muchísimas gracias a los organizadores por la invitación. Bien, mi presentación se compone de 4 elementos. La siguiente, por favor. En donde vamos a ver los derechos humanos al agua y al saneamiento, los tratados binacionales en relación con los derechos humanos en donde estamos, un tercer punto de hacia dónde ir, y el cuarto, para finalizar, algunos puntos de partida. La siguiente. Bien, Voy a empezar haciendo un repaso muy general de la definición de derechos humanos al agua y al saneamiento. Lo primero que hay que decir es que los derechos humanos parten de la dignidad humana, ¿no? Son las condiciones básicas, las condiciones mínimas para realizarnos y están protegidos por el más alto nivel de leyes y de tratados internacionales. Por tanto, están garantizados por cada uno de los estados, ¿no? Al estar vinculados a la dignidad humana, tienen ciertas características que son intrínsecas a cada uno de nosotros como parte de la humanidad. Entonces, son universales, voy a mencionar simplemente como estas características generales, no voy a ahondar en cada una de ellas, es solamente como dar un marco general de derechos humanos, un poco considerando que la mayoría de los asistentes el día de hoy son más de ciencias duras y de ingeniería, entonces así que por esto voy a ahondar un poquito en esto. Entonces, las características es que, bueno, son universales, son inalienables, están interrelacionados, son interdependientes, es decir, cuando hablamos, no podemos hablar del cumplimiento de uno solo de los derechos, sino que en general cuando aportamos al cumplimiento de uno, estamos abonando en el cumplimiento de los demás. Son indivisibles, por tanto, son inherentes a la condición humana, progresivos, e imprescriptibles, ¿no? Entonces, estas son como características básicas de los derechos que componen o constituyen la dignidad humana y por tanto son inherentes a cada uno de nosotros. De nuevo, es importante tener en consideración que están protegidos al más alto nivel, como vamos a ver ahorita. En la siguiente. Hablando específicamente de los derechos humanos al agua y al saneamiento, vemos, perdón, la anterior. Eso, aquí. Allí tenemos entonces el marco jurídico, voy a exponer el marco jurídico principal, ¿no? Es decir, esto está compuesto por diferentes tratados, por diferentes acuerdos internacionales, pero voy a mencionar simplemente uno que es la Observación General número 15 de la ONU, en donde el Comité de Derechos Económicos, Sociales y Culturales reconoce de manera oficial en el 2002 el derecho al agua. Entonces reconoce el agua como un derecho humano, ¿no? Luego, bueno, la Constitución Política de México se incorpora desde 2012 y Naciones Unidas aprueba también la Agenda 2030 para el Desarrollo Sostenible. Esta empieza a aplicar el 1 de enero de 2016 y allí también se reconoce el vínculo entre cada uno de los objetivos de desarrollo con diferentes derechos, entre ellos el derecho humano al agua, aunque para este hay un objetivo específico que es el número 6, ¿no? De todas formas, bueno, adicionalmente en 2010, la ONU reconoce nuevamente, ya el reconocimiento se había hecho en 2002, pero en 2010 reconoce que los derechos humanos al agua y al saneamiento están involucrados con el cumplimiento del resto de derechos humanos. Entonces acá les da como un carácter estratégico para el cumplimiento del resto de derechos y posteriormente, pues con los objetivos de desarrollo sostenible, esto se ve mucho más evidente. La siguiente. Ah, perdón, ya estamos en esta. Perdón, la anterior. Eso. Bien, ¿cuáles son las implicaciones de los estados? Cuando hablo de estados-nación, ¿no? Entonces, las naciones tienen unos deberes, o tenemos unos deberes, que son respetar, proteger, cumplir o garantizar y promover. Y esto es muy importante porque no son opcionales, sino que son deberes de todos los países, el respeto, la promoción, el cumplimiento y garantía de los derechos y también su promoción. Por otra parte, están unos criterios normativos que son cuáles son esos elementos que componen los derechos, ¿no? Entonces, estos elementos o criterios normativos son la disponibilidad, la calidad, aceptabilidad, accesibilidad y asequibilidad. Cada una de estas tiene unas definiciones como muy específicas, pero las voy a hacer así como a muy grandes rasgos, y es en términos generales, cuando hablamos de disponibilidad, es que haya agua suficiente y continua, calidad, que no dañe la salud, aceptabilidad, que culturalmente tenga color, el olor, el color, el sabor aceptable para la comunidad, accesible, esto se refiere a la distancia que debo recorrer para acceder a ella, y en asequibilidad es que todos puedan acceder a ella. En asequibilidad también se habla de los obstáculos físicos que puede haber allí, también en términos económicos, que no supere. Hay algunas propuestas, frente a esto no hay un consenso, pero hay unas propuestas que hablan de que no supere el 3% del ingreso total de una familia o de un núcleo familiar, etcétera. Entonces, estos son algunos criterios normativos que podríamos ahondar mucho en ellos, y cambian para el derecho humano al agua y para el derecho humano al saneamiento. Pero en general lo que garantizan es esta disponibilidad de manera permanente, sin que haya algún daño a la salud, que todas y todos podamos acceder a ellas y en ciertas condiciones, ¿no? Y también obedece a ciertos principios, como la igualdad y la no discriminación, es decir, igual para todas y todos. La responsabilidad y la rendición de cuentas es muy importante para el ejercicio de estos dos derechos. La sostenibilidad, es decir, pensar en las generaciones presentes, pero también garantizar el acceso al derecho para generaciones futuras. La participación, el acceso a la información y la transparencia. ¿Y por qué hablo de estas características y de estos principios en un contexto de derechos humanos transfronterizos? Y es justamente porque el tener como guía estos principios nos va a permitir tener un marco de referencia común para hablar de su implementación en el territorio. Entonces, cuando hablamos de sostenibilidad y de garantizar, por ejemplo, el acceso a este derecho, o garantizar más bien este derecho para las futuras generaciones, estamos necesariamente hablando de agua subterránea también, ¿no? No solamente de agua superficial. La participación de todos los involucrados también es un elemento importante en los acuerdos transfronterizos, como lo vamos a ver más adelante, y el acceso a información, que yo creo que es uno de los elementos claves y estratégicos para el buen funcionamiento de estos acuerdos transnacionales. Bien, entonces esto es importante no perderlo de vista: los deberes de los estados frente a los derechos, los criterios normativos y los principios para el cumplimiento. La siguiente. Bien, el segundo componente de mi presentación es acerca de los tratados binacionales y de los derechos humanos. Entonces, la pregunta es aquí, ¿en dónde estamos? Y en este sentido, simplemente voy a dar un panorama muy general. Las figuras acuíferos transfronterizos o aguas subterráneas transfronterizas todavía no tienen un rango constitucional en México. Y adicionalmente contamos con asimetrías entre los dos países en términos de información, de acceso a la información, de población, de usos que se le dan a las aguas y demás. En general, los tratados transfronterizos pues reglamentan el uso y el aprovechamiento de aguas. En general, las superficiales. Posteriormente, bueno, hubo como un desarrollo de este tipo de tratados pensados específicamente para las aguas superficiales. Después se pensó también, y pensados en términos de cantidad, ¿no? Posteriormente se ha abordado el tema de la calidad, en algunos casos de los usos, pero en general, pues las cuencas son compartidas, las cuencas no respetan límites establecidos legalmente. Y las cuencas pues son compartidas, tienen usos diferentes, su gestión cambia por su ubicación geográfica y esta gestión de las cuencas puede ser generadora de conflictos. Esto lo retomo al final. Y finalmente, pues el agua subterránea, así como, bueno, si hago la comparación con los derechos, el derecho al saneamiento también es un poco menos valorado y apreciado socialmente. El agua subterránea es algo que no vemos, que nos cuesta mucho, nos cuesta mucho generar interés en este tema. Entonces, en eso estamos, como en una... a pesar de que tiene un impacto muy importante en la economía, en el crecimiento y en el desarrollo, pues el agua subterránea no es del todo valorada. La siguiente, por favor. Bien. Tratados, entonces, binacionales y derechos. Entonces, ahora ya vimos en dónde estábamos y ahora vamos a ver hacia dónde ir. Entonces, ¿hacia dónde ir? Esta es una propuesta, es el marco regulatorio que permita una gestión integral y sostenible. Esto implica una perspectiva de cuenca completa, ¿no? A partir de principios de prevención y de precaución ambiental. Estos principios, el principio precautorio es simplemente la adopción de medidas que protejan frente a usos de tecnología o a determinados usos y que le apunten a proteger frente a un riesgo grave para la salud pública o la salud del medio ambiente, y esto es muy importante. Y la prevención, el principio de prevención que le apunta a generar o a evaluar impactos ambientales respecto a las actividades que posiblemente podrían generar un impacto desfavorable en un lugar que es compartido y que puede llegar a ser irreparable. Entonces, por eso es importante una gestión integral que parta de estos principios y pensar en una seguridad hídrica fundada en derechos humanos. Entonces, por tanto, los tratados o acuerdos deben promover esquemas conjuntos de gestión de aguas subterráneas fundados en derechos humanos. Y esto es muy importante porque los tratados, por lo general, están fundados en aspectos territoriales, geográficos y físicos, ¿no? Y el dar un enfoque de derechos, pues, implica unas concepciones distintas del mismo territorio. De nuevo, aquí establecer estos tratados fundados en derechos humanos nos implica de nuevo pensar en los criterios normativos que vimos hace 3 minutos, que son disponibilidad, calidad, aceptabilidad, accesibilidad y asequibilidad. Y esto debe orientar hacia la priorización, hacia su uso ambiental y doméstico, por supuesto, y reconocer la importancia para el bienestar socioambiental en su conjunto. Finalmente, la siguiente, por favor, para no salirnos del tiempo, algunos puntos de partida. Entonces, primero, tenemos un reconocimiento internacional que nos da un marco legal general. Entonces, por su parte, las Naciones Unidas, en el Plan Nacional de Adaptación, recomienda esto que ustedes ven en la pantalla: evitar impactos transfronterizos negativos, especialmente en cuencas fluviales compartidas u otros ecosistemas. Y también la inclusión e implicación de todas las partes interesadas relevantes. Entonces, tenemos eso como un punto de partida. Por su parte, la OEA exhorta a sus estados a reafirmar compromisos asumidos a nivel regional e internacional relativos a la gestión integrada de recursos hídricos, justo lo que acabo de mencionar. Esto es garantizar acceso igualitario, equitativo, no discriminatorio, justo al agua, ¿no? Y promueve la cooperación técnica, bilateral y regional entre los países miembros, particularmente en lo que se relaciona con la gestión de recursos hídricos. Entonces, este es un punto de partida inicial. La siguiente.
Un minuto, Caro.
Ok. Tenemos el enfoque de derechos humanos, que implica acceso a la información, a la participación, a la toma de decisiones, a la justicia y demás, de nuevo con los criterios que ya mencioné. Y la siguiente, la que sigue, por favor. Bien. Esto como un punto de partida importante es, bueno, la hidrodiplomacia bilateral orientada a la prevención del conflicto, el cierre de brechas, el reconocimiento de actores, etcétera, pero quiero dejarme o quiero puntualizar en la pregunta que hay al final, que es el derecho humano al agua como límite soberano de la humanidad. Esta es una pregunta. ¿Es posible pensar entonces en el derecho humano al agua como ese límite soberano de la humanidad? Tenemos por una parte el marco legal ya está establecido porque la protección de derechos humanos es un interés común y es respaldado internacionalmente. Por otro lado tenemos un marco espacial que es la cuenca trasciende las fronteras físicas y políticas, por lo que el territorio nos daría ese marco espacial, planteando el territorio más como una construcción histórica, ¿no? Que reúne formas de apropiación de las personas en un espacio conformado por aspectos físicos, sí, naturales, paisajísticos, culturales, etcétera. Entonces, esto nos da un marco espacial y finalmente un marco de aplicación, que es la humanidad, ¿no? La humanidad como un marco de ejercicio y aplicación de esos derechos que nos darían esos tres elementos la posibilidad de pensar en el derecho humano al agua como un límite soberano más que un acuerdo o un tratado internacional. Es todo, muchísimas gracias.
Muchas gracias, Caro.
Bien.
Thank you, Dr. Carolina. Thank you for that. Now we're a little bit short in time. We'll move. We're going to leave questions at the end. I'm going to move with Dr. Edith Koffer, who's going to be our second speaker for this theme lecture. She has a PhD in political science at, I'm very good at French. So, I mean, I'm not very good at French. Probably Alfonso could do this better than me, of Marseille University, and is a senior research at Centro de Investigaciones y Estudios Superiores en Antropología Social, Sureste México. She's a fellow at the Collegium de Lyon, France, former coordinator of the Researchers Water Network on the border between Mexico, Guatemala, and Belize, co-coordinator of the Comparative Research on Regional Integration and Social Cohesion Consortium, working group on management of strategic resources, environment, and society. She conducts research on transboundary waters and river basins, water policy and politics, gender and water in southern Mexico, North and Central America, and the Mediterranean, and more recently on sediment extraction. Welcome, Dr. Koffer. Please take over. Your presentation should be there.
Thank you very much, and good afternoon to all. Thank you for
Edith, if you're listening to me, please make sure that you select the English language.
Okay.
Below on your interpreter. Okay, and then mute your original audio. Okay.
It's okay?
Yes.
Okay, so thank you very much for the invitation to this conference, and I would like to invite you to travel to a very different context. And in this context, it is impossible to evoke transboundary groundwater issues because those are not issues at the moment. We have about 7-8 decades of delay of time lag. I don't know which word is better to explain this regarding transboundary waters in the south of Mexico, and in the context of Mexico, Guatemala, and Mexico and Belize borders. Next slide. We find deep diversity in the so-called southern border of Mexico because we have really two transboundary contexts because of history, politics, and water issues. We have two neighbors, Guatemala and Belize. We have two borders, and on the Mexican side, we have 4 states, Chiapas, Tabasco, Campeche, and Quintana Roo. We have also plenty of water. That means 3 international rivers, the Suchiate, Usumacinta, and the Rio on the river. We have 6 transboundary river basins, shared wetlands, lagoons, shared lakes, and plenty of transboundary currents flowing from Guatemala to Mexico. And a big diversity of transboundarities, borderities phenomena, where water is a division, but also an important point of connection between people. And in this context, we find problems of access to drinking water and sanitation because of lack of public services. You can see on the picture on the Guatemalan side of the Usumacinta River, women are washing in the river, and because of remoteness and state's omissions. Next slide. On the map, you can see the 6 transboundary river basins, Suchiate, Coatán, Grijalva, Usumacinta, which is trinational. A small part is located in Belize, Candelaria, and on the river basin, which is divided into the 3 countries. And you can see also on the right a picture with the dividing line in a transboundary lake. Next one. We share plenty of water. You can see on the map on the left, if we cut if we put all the of surface waters and we cut 30 kilometers on both sides of the border, we have a lot of plenty of waters. And we also share different realities. On the other map, you can see fire ponds at the beginning of 2019 in the transboundary Usumacinta River Basin. Next one. We also find in this transboundary context some contrasting realities, political and economical asymmetries. On the Mexican side, we have the biggest dams of Mexico, some of the biggest dams of Mexico, and we also find many water conflicts relating with the building of dams and mining activities and so on. Next one. And we also observe water and sanitation shortage, as we can see on the left in Belize, and close to this location, tourism activity, as we can see in the same river basin in Mexico, in Bacalar, Quintana Roo. Next one. So on South, we have recently a recognition of water transboundarities. That is a significant achievement. We still have a lack of transboundary cooperation on water issues. We have no treaty, no agreements on sharing water in the South with Guatemala and also with Belize. Nevertheless, we find local experiences and initiatives, but also local conflicts. And transboundary water issues are not on the policy and political agendas between Mexico and Guatemala, Mexico and Belize, for historical reasons, for sovereignties, excepting on the river between Mexico and Belize, only between these two countries, where we have now some attempts to build a cooperation. What about data about water and sanitation in the region? It is important to mention that the table show us official data, and when we go to field work, the situation could be something different. On the Mexican side, the state of Chiapas is lacking of opportunities for people to access to water, to drinking water, and sanitation in the border. We have an important gap between urban areas and rural ones in Mexico, but also in Guatemala and Belize. The data from Guatemala and Belize don't correspond from my perspective to the reality that we find in fieldwork. Next one. So what about the human right to water and sanitation? If we adopt a normative focus, it's important to understand that in Mexico, regarding the last the recommendation of the United Nations High Commissioner, Human Rights Committee rapporteur, we can find that 40% of the recommendation has not been attended, 10% with insufficient information, 30% with limited information, and only 20% of the recommendation are in progress. And it is important to notice that it includes transboundary consideration, but only between Mexico and the US. The so-called southern border doesn't exist in these recommendations. Regarding the Central American normative framework for Guatemala and Belize, we have a regional framework law on human rights to water and sanitation, which was approved by the President's National Legislative Assemblies in 2015. And we have also the Central American and Dominican Republic Drinking Water and Sanitation Forum with a strategic plan to enhance Central American institutions and to promote national regulation in these issues.
We need 1 more minute.
Yes, okay. Regarding human rights to water and sanitation and transboundary issues from a normative focus, at national scale in Mexico, as you know, it isn't included yet in the law, but yes, in the constitution. Guatemala and Belize, it doesn't appear in the law, in the constitution. In Guatemala, we don't have a water law. And regarding transboundary water issues, Mexico, Guatemala, and Belize are not part of the international conventions. Neither we find bilateral treaties between the 3 countries. Next one. Next one. So I would like to conclude with three questions. How to entangle transboundary water issues with human right water and sanitation, how to transcend national borders and security to build a minimal consensus on shared water issues, and how to convert local and transboundary water conflict into human rights compliance. I think that the new water laws are opportunity to revisit human rights and international principles and related debates on human rights, water and sanitation. And I think that we need more research on local realities regarding transboundary issues and processes about the two mentioned border context, and not only between Mexico and the US. Thank you very much.
Sam, do you want to take over
we have here a couple of questions.
We have a couple of, yeah.
Yeah, for Carolina. Oh, I have it here. So, which water source? This is a question from Joel Carrillo. Which water source, surface water or groundwater, is meant to be used to comply for human right, well, the human right to water? And then the second one is which actions have been taken to implement actions in rural areas? Carolina.
Bien, gracias por la pregunta. Bueno, el cumplimiento de los derechos es obligación derivada de tratados internacionales. Entonces, es una obligación su cumplimiento, pero no se especifica cuál debe ser la fuente. Es decir, puede ser a través de agua superficial, subterránea, incluso para su cumplimiento se ha usado también agua de lluvia. Así que no es específico en cuanto a eso. Y las acciones que se han tomado para implementar acciones específicamente en el ámbito rural, bueno, en México se han tomado varias, hay programas específicos para apoyo al ámbito rural, sin embargo, considero que han sido limitados, sobre todo porque se han remitido más a infraestructura tradicional para lugares que no son tradicionales. Entonces tenemos zonas rurales con una geografía difícil, con un acceso muy problemático, y entonces allí la opción sería tecnologías apropiadas, captación de agua de lluvia, captación de humedad, etc. Y por otro lado, el reconocimiento de la gestión comunitaria del agua también es una tarea pendiente. Esto es una de las observaciones del relator que no se ha dado cumplimiento. Y la gestión comunitaria del agua ha garantizado el cumplimiento de estos derechos a lo largo de muchos años, y aún en México no cuentan con reconocimiento. Estamos apuntando hacia allá, pero todavía es una tarea pendiente. Gracias.
Yeah, now, yeah, thanks. We have another question now. This is for Edith. This is a question from David Guevara. Is migration from Central America to some extent driven by water-related issues? Edith?
Edith, did you get that question?
La puedo contestar en español.
You need to select the English. If you're going to speak in English, you need to select the English. Yeah.
Okay. So,
o en español, si quieres hablar en español, como quieras.
Pero lo cambio.
So whichever language you want to answer. You're going to use Spanish now?
Edith, sí, es lo que te iba a decir, te andaba buscando. Si quieres, en la barrita de abajo está el de español.
Voy a contestar en español sobre la migración. Estoy en el canal adecuado, perdón, estoy perdida.
Dame un segundo. En la barra de abajo, Edith, de la pantalla, debe de venir un globito. En ese globito, dale ahí en español y luego ponle Mute Original Audio. O sea, primero seleccionas español, mute, y ya habla en español.
Ok. Bueno. Bueno, la pregunta es sobre si la migración de Centroamérica tiene que ver con los asuntos del agua. Bueno, es muy compleja la pregunta. Digamos, sí obviamente, no lo he mencionado, pero las dos fronteras, porque para mí sí son dos fronteras, es importante, eso es un punto muy importante porque son bien diferentes. La mayoría de estas fronteras es agua, ¿no? Y entonces justamente los ríos que tenemos dividen, pero pues también permiten conectar. Y la relación entre el agua, estos ríos y la migración es muy estrecha, porque son puntos por los cuales las personas transitan, ¿no? Entonces, desde ese punto de vista, efectivamente sí tenemos una estrecha relación. La gente, ustedes conocen seguramente las imágenes tradicionales del río Suchiate, donde pues en las balsas pasan los migrantes, y a pesar de que Guatemala recientemente cerró sus fronteras por el COVID, bueno, la gente sí siguió pasando, ¿no? Entonces sí hay una estrecha problemática. Ahora, en términos de cooperación transfronteriza en temas de agua, en realidad creo que son temas completamente desconectados, ¿no? En el sentido que la migración tiene que ver estrictamente con temas de seguridad, y el tema del agua, bueno, donde no pasa nada, ¿no? Porque no pasa nada entre México y Guatemala en particular, aunque hay un conflicto abajo que no está dicho, ¿no? Pero sí hay muchas tensiones, pero no hay ninguna cooperación, no hay nada entre ambos estados. Eso conforma algo muy diferente de lo que pasa en la cuestión migratoria, donde hay una serie de políticas sí enfocadas hacia la seguridad, etcétera, etcétera. Entonces, por un lado, sí está estrechamente vinculado en la experiencia de los migrantes, en la experiencia de la gente, pero por el otro lado, a nivel de estados, considero que están completamente desconectados las temáticas a nivel de político y de high politics.
Edith, muchas gracias. Vamos a una pregunta. Tenemos dos preguntas finales antes de irnos al break. Vamos, muchachos, sí podemos llegar. Esta es para Carolina. Dice, es muy interesante lo que nos has presentado. Esta es una pregunta de Marucia. Dice, el gobierno de México está intentando redireccionar los proyectos al aspecto social, pero me surge la duda de cómo hacemos para empatar todo esto del derecho humano al agua con la productividad económica. Por ejemplo, la obtenida desde la agricultura. Lo comento porque esto es un serio problema hoy para nosotros en el estado de Chihuahua.
Bien, gracias por la pregunta. Bien, sí es un problema empatar las prioridades, ¿no? Pero yo creo que el derecho humano establece el derecho humano al agua establece unas prioridades en el uso, ¿no? Entonces, el uso primordial es el uso para consumo humano. Posteriormente está, sí, este uso para la agricultura, porque de allí surgen los alimentos y demás. Pero yo creo que lo que debemos pensar es en un cambio estructural del modelo de producción. El agua que se dedica a la producción en muchos casos no es para una producción de consumo, no es una agricultura consumo, sino más de agroindustria. En términos del uso para agroindustria, yo creo que allí es replantearse el modelo y es en qué estamos utilizando el agua dedicada a la agricultura. Si es agricultura para el consumo local y para el consumo regional tal vez, o es agroindustria para alimentar otras industrias, o deja de ser un uso orientado a la garantía de la alimentación y más está orientado a unos fines comerciales. Yo creo que son más las preguntas que debemos hacernos y sobre todo pensar cuáles son las preguntas que nos van a orientar la toma de decisiones respecto al uso del agua, sobre todo en espacios fronterizos y bueno, y fuera de ellos también. Listo, gracias.
Muchas gracias, Carolina. Edith, La última y nos vamos. Entonces, una pregunta de Luzma. Se pregunta para Edith. Dice, pensando en los estados mexicanos que comparten aguas con Guatemala y Belice, ¿cómo los políticos y las sociedades locales perciben y aprecian el vivir dentro de una cuenca compartida? ¿Es interiorizada la noción de cuencas compartidas en el ámbito sociopolítico? ¿Y qué consecuencias ambientales derivan de esta situación?
Bueno, es muy compleja la pregunta. Voy a intentar enfocar alguna respuesta. Creo que los políticos no perciben las cuencas transfronterizas ni a nivel local ni a nivel federal, escasamente. Las poblaciones creo que depende. Una cosa es vivir en la cuenca del río Suchiate, que es chiquitita y donde probablemente sí se perciba. Y otra cuestión es vivir en la cuenca del río Sumacinta, que es enorme y creo que hasta cierto punto no se percibe, salvo para los movimientos de defensa ambiental que tienen al territorio de la cuenca como espacio de defensa y espacio de lucha. Ahora, creo que depende mucho donde uno vive, en qué parte de la cuenca. Lo que sí se percibe mucho es que el agua viene del otro, fluye de un lado al otro y que viene de Guatemala. Entonces se percibe más, sobre todo cuando uno vive de un lado o del otro de Sumacinta, se sabe que del otro está Guatemala, no necesariamente en términos de cuenca, sino en términos de recursos compartidos. Pero bueno, creo que las realidades pueden ser muy, muy distintas según la cuenca, según en qué parte de la cuenca se vive, si se vive cerca de un espacio, no sé, un humedal transfronterizo, etcétera, etcétera, ¿no? Entonces puede haber muchísimas respuestas. Pero sí, desde mi punto de vista, los políticos poco o casi nunca lo perciben. Gracias.
Muchas gracias a las dos. Muchas gracias. Rosario.
Thank you.
Thank you, Samuel. Thank you, Edith, Carolina, for that insightful, very complex topic. It's not easy to talk about humans and not about their rights, and then environmental rights, and then, economic rights, and then political rights, and everybody has its rights. So with these last presentations, we're going to end the morning session morning session. We're going to have a lunch break right now. We're going to come back at 4. We're going to have another theme lecture and another panel in the afternoon. Please stretch your legs, have a lunch, check your kids. If you have time, send us your calavera. You still have time to send us your calavera for the happy hour. We have a surprise for you in the happy hour. It's going to be fun. So thank you, everyone, for staying all this time this morning. We know it's hard being here, but we probably didn't have this much of audience in person, at least not this binational really group at this level. So those are the good things of technology these days. Anyway, thank you, everyone, and see you at 4 p.m. We're going to be here if you need anything. If you want to send questions, we're going to be here with some music. You can walk around and we'll still be here. So thank you, and let's have a break.